This is our second commercial spaceflight panel we are bringing to you this year. Our first one was in February, and it was very successful that we decided we wanted to do it again. But this time, instead of just focusing on the orbital companies, we wanted to invite our suborbital friends from Dallas and California to teach us a little bit about their market, since we don't get exposure to that here in Houston. If you tweet, I invite you to tweet while you're here tonight. Share information with the world. We have our SpaceUp HOU account, and then we have CSF Capture Flag account that we're going to be tweeting from as well throughout the evening. I just wanted to share with you our sponsors for tonight's performance. Oh, wait, it's not a performance? So Boeing, ULA, and Sierra Nevada Corporation are our three largest sponsors, and we're very grateful to them. They are our 2011 sponsors, actually. And then for this specific event, Schipul and Gulf Coast Film and Video are helping us out by streaming the event online. So we have an online audience. And what we're going to do with them is Sarah in the back from Schipul is monitoring the web stream and their chat conversation, and will bring their questions into the presentations and the Q&A for us. So we'll archive the video and we'll post it to YouTube. So you had such a great time here tonight and you wanted to go back and reference something, it'll be available to you, or you want to share it with all your friends. So for that, I appreciate it. Okay, so there's our sponsors. The next thing I want to show you is, you may have heard that during 135 a flag was taken up to the space station, and Obama had a chat with the crews, and it kicked off this thing called Capture the Flag. And the idea is the flag, flown on STS-1 and then flown back up on STS-135, was left on board the space station. The idea is the first commercial spaceflight company to go and dock and bring a crew to ISS gets to bring the flag home. So we're off on a race, a safe race. But we're promoting it. And you can follow at CSF for Commercial Spaceflight Capture Flag. That was the best I could do. Capture the Flag was already taken, imagine that. And we have people across the country tweeting on behalf of the different companies. And so they're following your news stories, and if you're doing press conferences, et cetera, and they'll be tweeting out information to try and grow the enthusiasm around this design development and test phase as we go over the next few years. Crew, right, yes. Okay, so just to give you an idea of the format for tonight, each of the companies are going to do a presentation, and then we will do a Q&A where you're welcome. I think we're going to have a mic set up in the back room there, and then you can come up to this podium and ask questions. And they'll all be sitting up here at the table. And then following that, if you want to network in the lobby, you're more than welcome to. So I'm going to turn the computer over to Kat, who's going to run it. But first, what I want to do is introduce our panel speakers to everybody. And starting with our suborbital companies, we have Virgin Galactic, Will Pomerantz, who's here for VP of Program Management. No, VP of Special Projects. You want a new title? I gave myself a title at work the other day. I self-promoted myself. At first I thought Director of Fun. That didn't sound right. So now I am the Social Director of all things fun. Okay, so next up we have Neil Milburn, VP of Program Management from this company up in Dallas. Supreme Command. Oh, that didn't come across in the email. I missed that. He's from Armadillo, our neighbors up in Dallas. Then we have McKee from XCOR, Program Manager. And Mike Burghardt from the Boeing Company, Director of Spacecraft Development. And we need somebody to launch us into space. So ULA is here, Jeff Patton, BD and Advanced Programs. And Sierra Nevada, their Dream Chaser spacecraft, John Curry, Director of Spacecraft Advanced Development. SpaceX originally was going to come and join us. However, they had a milestone fall on today's date, and we were going to WebEx them in. However, this would not have worked. The audio does not feed into the room, so you wouldn't have been able to hear them. So they promised they'll come next time, and they were here the previous time. So they and us give our apologies. Okay, with that, from Suborbital, who wants to go first? Virgin Galactic, all right.
Make sure the projector is working. I think you just unplugged it.
Oh, did I?
Yeah.
Okay.
There you go. You going first, Will? Yeah, don't press the self-destruct button, Will.
Okay.
It's never
This
good.
big red one.
Exactly. Oh, yeah. Thanks for the call. You want B or C? I thought we'd like to C. Or is B better for you? This is C. Is that better? Okay, there you go, Will.
All right. Hello, everyone who I now cannot see. I will assume that you're waving back at me. Hi, my name's Will Pomerantz, as the introduction heard. I guess there was a little bit of title inflation going up down the end, so if I were more creative, I would have come up with something really impressive by now. It's wonderful to be back in Houston. I lived here when I was a little kid, haven't been back in a while, so thanks for the excuse to come home and visit again, and to have a chance to speak with all of you and speak alongside some of my friends and some companies that I really admire here in the industry. I wanted to just give you a quick overview of who we are at Virgin Galactic, the road we've traveled to get to where we are today, and what we think is in the future. Some of you may already be familiar with Virgin Galactic, so apologies for recovering any old ground, but I wanted to make sure we have the right footing before our question and answer session. So I wanted to start with this number right here. This is maybe plus or minus 1 or 2, depending on your definitions, the number of human beings who have been to space in the history of the world. This, starts with Yuri Gagarin and goes all the way through the crew of 135. And I personally find this number simultaneously incredibly uplifting and kind of depressing. It's incredibly uplifting because, of course, for every other species in the history of life, as far as we know it, this number is 0. And the fact that it's non-zero is amazing. It's kind of depressing because certainly when I was a kid, and I bet for most of you, you thought by the time 2011 rolled around, this number would have several extra zeros tacked on to the end. But I think the fact of the matter is that it is not NASA's job to care that much about this number. And it's not the other national space agency's job to care about this number. It just isn't. It's not to say that the brilliant folks here at JSC and at the supporting contractor companies couldn't increase that number if they were asked to. They haven't been asked to. But I think that there's a big pent-up desire to see this number grow larger. I would bet if we summed up all the people in this room right now and watching on the webcast and asked how many of them wanted to go to space, we would already be approaching the number of 523. It's clearly multiple orders of magnitude larger than this, the number of people who would happily go to space, who would happily pay a lot of money or spend a large portion of their life in training for the opportunity to go to space. So I think that sort of demonstrates that there is a market, there is a commercial need, there's this pent-up desire for some sort of capacity that will allow us to carry human beings into space on a much more frequent and routine basis than we've seen in the past. And we also have this nice existence proof that that is indeed possible. As many of you are familiar, in 1996, this nonprofit organization called the XPRIZE Foundation, at which I had the privilege of working for many years, offered up a $10 million technology incentive prize for the first privately funded company capable of building a spacecraft that could carry 3 human beings or their weight equivalent into space 2 times within 2 weeks. And the idea was that because of that particular mix of rules, had to be privately funded, had to go multiple times in the span of just a couple weeks, had to go at least above 100 kilometers, that would sort of demonstrate in a very real way the fact that commercial companies could do this, that they could do it safely, that they could do it routinely. The thought was, if you've flown again in just 2 weeks, chances are your marginal cost for a flight was just the cost of fuel plus maybe a person day or a couple person days of labor. And that starts getting a lot more like aircraft operations, which, as we all know, probably a lot of us were on airplanes just within the last 24 hours. I certainly was on a couple of them trying to get here. When that prize was offered up in 1996, I know in general the reaction among the community was that this was a cute thought experiment or maybe a stunt, but that it would never get won. I don't mind saying that because I think that was my personal impression when this prize was first offered. But thankfully enough bright people didn't believe it was a joke and seriously put their efforts into it. And that ultimately did culminate in this vehicle, Spaceship One, successfully flying to space actually 3 times over the course of the summer and fall in 2004, including 2 space shots in about 6 days in the end of September and early October of 2004. This vehicle, Spaceship One, now hangs in the Milestones of Flight Hall, the main foyer in the Smithsonian Air and Space Museum in Washington, D.C. And this vehicle, I should point out, was the product of just over $25 million in investment and something on the order of 100 person years. So certainly in terms of the space industry, that's a pretty small program, extremely small when it comes to human spaceflight, but pretty small even for any kind of spaceflight. And it was something that would show the sort of cold-hearted investors, in addition to the diehard space geeks, that commercial spaceflight had potential, had a future. It was enough to attract the attention of my boss, or more accurately, my boss's boss's boss, or something like that, a guy named Sir Richard Branson. Sir Richard, as many of you may know, is the founder of the Virgin Group. He is a very wealthy guy. He's a very dynamic guy. He's a very ambitious guy, and he is a guy who has a lifelong dedication to adventure and specifically to aviation. He's a guy who's taken on, attempts at least at record-setting balloon flights, who sponsored the first round-the-world single-person nonstop aircraft flight, et cetera, et cetera. So we sort of had this proof that this was possible. And Virgin decided to team up with Scale Composites, the technical firm that had designed that vehicle, to create what we hope will be the world's first commercial space line. And this involves setting up a couple of new companies. We have Scale Composites, which has been around, in one form or another since essentially the 70s, has this long legacy of home-built aircraft, experimental aircraft done for the Department of Defense, done for NASA, done for a variety of private customers. And then we, Virgin Galactic, we're a new company. We are set up ultimately to be the space line. We want to be like a Southwest Airlines or a Continental Airlines, although hopefully with better customer service. But because we couldn't go out there and buy a Boeing 737 or an Airbus A320, we had to hire somebody to design those vehicles for us, and we hired Scale Composites. And then we jointly created a company called TSC. It's a joint venture between Scaled and us. I should point out Scaled is now owned entirely by Northrop Grumman. And TSC's job will be to mass produce the spacecraft I'm about to show you about. I should certainly put in a plug to say TSC is hiring now in a major way. There's something on the order of 25 jobs open on the website right now. I think TSC had maybe 20 employees at the beginning of the year. They're at 70 now. They want to be at 115 by the end of the year, 150 by this time next year. So for those of you who are maybe looking for new opportunities and interested in coming out to Mojave and working in a spaceship factory, please either see me afterwards or check our webpage. So I showed you that existence proof of Spaceship One. That was a great vehicle, but it was really a prototype vehicle. It lacked a lot of creature comforts that you would think you'd want to give to an astronaut who's paying an awful lot of money, at least certainly by my standards, to fly to space. It also, cut a number of corners in terms of the engineering of the vehicle because it was designed to meet a goal on a certain timeline. We decided to commercialize it. We really wanted to scale it up, and so we had Scale Composites design a new set of vehicles. It's a 2-vehicle set, so we have the White Knight 2 mothership, and then it carries under in the center pylon there Spaceship 2, which is our suborbital spacecraft, and these are to scale so you can get a sense of the relative size of the two. Whereas Spaceship 1 was designed to carry just 3 people and only ever actually carried 1, Spaceship 2 is designed to carry 8. That's 2 crew members and then 6 paying passengers. We have been taking deposits for a number of years now. We've now taken almost 450 deposits. Ticket prices are $200,000 a pop, although you don't have to put down that much right at the beginning if you don't want, but the more you put down, the sooner, the faster you fly. So we've taken about $58 million or so in deposits thus far. These are the vehicles. They're built. This is not PowerPoint slides. This is not CAD drawings. This is a real photograph. In fact, those of you with sharp eyes might recognize the Golden Gate Bridge in the background. This is when we flew the vehicles up to, we flew them into SFO, the San Francisco airport, for a publicity event for one of our sister companies, Virgin America. Let me walk you through the flight trajectory. The flight trajectory for Spaceship 2 will look a lot like it did for Spaceship 1, if any of you recall seeing that vehicle fly. So we take off under the mothership, White Knight 2, on a regular runway, a 10,000-foot runway. We will sort of slowly coast up to just over 50,000 feet under white night. And that'll take up actually most of the time that you spend from wheels up to wheels down. Maybe somewhere on the order of an hour you'll spend sort of slowly spiraling up to that altitude. Do a number of checks on the vehicle, make sure everything looks exactly how we want it to. And then much in the way that the X-15 did or the other earlier X vehicles, or like Spaceship 1, we'll release Spaceship 2. It'll free fall for a few seconds, long enough to make sure that we're well out of the way of the mothership. Light up the engine, and I'll show you some pictures of the engines firing later, but it's the world's largest hybrid rocket engine. That will fire for somewhere on the order of the minute, on the order of 1 minute, carry you up, including cruise time, to an apogee over the Kármán line, the official boundary of space, which is 100 kilometers. We're shooting to get to 110, something like that, so you get your astronaut wings with some room to spare. Then while we're up there, probably the most innovative thing about this vehicle pair, which was derived directly from Spaceship 1, is what's depicted here. This is called feathering the wings. And sort of in brief, what we decided was that there were some advantages to re-entering the atmosphere like a capsule and some advantages to coming back to Earth like a winged vehicle. And we wanted the best of both worlds. So what the heck, let's build a transformer and have a vehicle that can fold its wings up to about 65 degrees relative to the body. That allows you, when you've got the wings folded up and you're just beginning to re-enter the atmosphere, to enter in what we call a carefree or hands-free fashion. The physics of this is much like if you've ever thrown a badminton shuttlecock. No matter which way you have it oriented in your hand, when you let go, it quickly orients to be heavy side forward. We similarly, even if we're having a day where maybe the vehicle is not as tightly as controlled as we wanted to, it will quickly right itself, and we know exactly how it's going to enter the vehicle. It also allows us to spread the heat over a much larger area. And clearly, coming back from suborbit, we don't need to deal with exactly the same thermal issues that you'd have with an orbital vehicle. We are in flight test now. We just flew the White Knight, I think yesterday, or was it the day before, on its 69th flight. The Spaceship has been carried underneath White Knight 2 a total of 27 times. On 15 of those occasions we have released it, and on 2 of those occasions we have feathered up the wings. This is a photograph from one of those. So we're in this phase right now where we are testing the rocket motor separately from the aerodynamics of the aircraft and kind of getting all the kinks worked out of those systems separately before we integrate them. Very pleased with how the vehicles are performing. This is a photograph of the rocket motor firing. Again, we've fired 6 of a full-scale assembly, not for the full duration yet, although we'll be getting there in hopefully the not-too-distant future. This is also a scaled-up version of the rocket that was space-proven on Spaceship 1. The chemistry, for those of you who are wondering, is essentially tire rubber and laughing gas. We ultimately want these vehicles to be positioned all over the world because we want to be servicing everyone who wants to fly. But at least in the initial going, we have partnered with the wonderful state of New Mexico, which has built the world's first purpose-built commercial spaceport called Spaceport America. It is nestled right up next to White Sands Missile Range. And those of you who work at JSC and have had a chance to go out to White Sands know the many advantages that New Mexico has in terms of good weather, a reasonably high starting altitude, and a giant block of controlled airspace, which we think will ultimately really work to our favor. So as you can see, the runway's already been poured and dedicated, and we're in the construction phase of the spaceport itself. This is it as you approach it from the main road. It's really a cool-looking facility. The folks in New Mexico have done a spectacular job designing something that, from a distance, absolutely blends into the local environment. And then all of a sudden you turn a corner and it looks like the spacecraft has just sort of descended in front of you. Thank you very much. So I should say, thus far I've focused on suborbital space tourism. And for the most part, that's what we at Virgin Galactic are known as a suborbital space tourism company. That's because, that was the immediately obvious business market for us. And I suspect for a lot of the other people in the industry as well. Those were the people that we knew we could go out, and as soon as we announced this, if we announced it with a certain level of credibility, we could start taking ticket deposits right away. And even though we don't spend any of that money, it's nice to have that. It gives the messages that you want to give to your investors. But we think that ultimately that's not the only market. And in fact, we're already starting to see some proof positive of that. Just last week, we, along with XCOR and Armadillo and I guess 4 other companies, were selected by NASA to start flying autonomous scientific experiments on high altitude and in our case suborbital space flights. We think that that's a great market. It's both part of our business plan and part of our sort of corporate responsibility. We have similar deals with NOAA and with some private institutes like Southwest Research Institute just up the road in San Antonio to fly, in some cases, autonomous experiments, and in some cases, scientists and their experiments on suborbital flights. And again, that's something that maybe just because of the way this country funds science wasn't going to be the first market, because there's always a lag between a capability being developed and scientists having the grants necessary to take advantage of that. But we think it's a significant market. And then I'll also say that we ultimately have designs to go farther than suborbital. As I mentioned, Sir Richard is quite an ambitious guy. In his opinion, if we do suborbital today, we should be going point to point tomorrow and orbital the day after. We try and convince him that maybe it's not quite so simple as that. But we absolutely have those things in mind. We recognize that there are a lot of business opportunities there as well. So I think I'm about out of time, but I will just, again, put in a plug to say that we are hiring now, not quite so much on the Virgin Galactic side, but very rapidly on the TSC, the spaceship company side. Hiring everyone from engineers, a lot of technicians. We really value if you've done hands-on labor, if you've built an aircraft yourself or done home projects. That's certainly something that we view very positively. So thank you very much.
Thank you, Will. That was excellent. Next up, you want to go? All right, Neil's going to share with us about Armadillo.
Might need your help to get those little videos. Is the sound hooked in as well?
Yes. Yes, yes.
Security man. Okay, this is good.
Uh-oh, you're a security risk. Watch out, Neil. And Neil, if you there's a clicker for you too, and then I can click the videos if you need.
Yeah. You can,
So.
if I can see which button does what. Okay. Okay, my name's Neil Milburn. I'm the Vice President of Program Management for Armadillo. We're a Texas-based company. It's like standing in the spotlight here. We would love to fly out of Texas. I know our buddy Ricky T's back somewhere there trying to work it for us, but we too will be flying out of New Mexico, at least for the foreseeable future. We don't quite have Branson's deep pockets. We were started by a guy called John Carmack and his wife Anna 11 years ago now, and it literally was a hobby company at the time. We operated out the back of a small shop in Dallas, Texas. It actually belonged to another one of the team members, Russ Blink. If you've ever been to a restaurant and you got those little pager things, he's the guy who invented those, and I think his company used to have like 50-60% of the market for them. And but our rocket business kept creeping into his daytime business, so he eventually threw us out, and we took over another small shop. And then since then, this has really grown into a real industry. It was just hobby. We were all part-time up until about 4 or 5 years ago. And there's now a grand total of 7 of us working full-time out at beautiful Caddo Mills, Texas, about 40 miles east of Dallas. We actually fly rockets out there. Some of you may have been out and seen some of the test flights we've done. Whoa, that didn't look good, did it? Try that one. This is some of the most recent history. It's actually kind of, as far as we're concerned, these are all legacy vehicles now. It was interesting listening to Will talking about the original X Prize that Peter Diamandis set up. I remember coming down to Houston. We had a little celebration, and we handed Peter a big cardboard check for, I think it was $5,000, which was our entry fee into the X Prize. And the next week, Bert wheeled out Spaceship 1 and White Knight. We go, oh, hell. we've got a bit of work to do here, boys. Having said that, I mean, we're big fans of all of these commercial space companies because a success anywhere in this industry is a success for all of us. It's a rising tide syndrome. So although we would prefer the 10 million ourselves, we were quite happy when it was actually done in the time frame. When that was over, Peter announced the original X Prize Cup, and then the Lunar Lander Challenge, which was the NASA Centennial Challenge Office and Northrop Grumman. And we're known for putting stuff together really quickly. And that quad in the top left-hand corner, that pixel, went from a drawing on a napkin in a pub in Phoenix to a flying vehicle in 6 months. Pixel never did. She's flown hundreds of times. It's actually owned now by JSC. We sold it to them under a part of a co-op agreement. And they use it as kind of a hands-on tool for folks so they can actually play with rockets instead of just playing with them on laptops. But it never actually did win anything, but it was a good flying foundation. We replaced it later with the Supermod, in fact, the one down in the bottom left-hand corner there, and a couple of different variants. That won the Level 1 prize. We'd like to say it won the Level 2. It was a bone of contention at the time. It was actually the first one to do it, and there was some little jiggery-pokery going on. But again, it was a good learning tool for us. It provided a nice short-term goal. We developed a lot of good technologies with the Supermod. From that came a modified version of it. These were only designed, the early ones, to go up to about 50, 100 meters and translate and precision land. And I say only, it was a pretty phenomenal feat. For at that time, I think there was 5 of us working part-time on those vehicles. And that vehicle has the same delta V as the original lunar lander going down into descent or ascent. Had to fly it up 50 meters, translate 100, land on a simulated lunar surface. That's our simulated lunar surface at Caddo. Refuel it and fly it back again. Same mission profile. Had to be in the air for 3 minutes on each flight. And you had to do all that in 2.5 hours. And I think we were eventually knocking those flights out in less than 2. So a pretty phenomenal achievement for a bunch of guys working out of a garage back in Dallas. The mod vehicle Dalek had a fairly ennoble history. It was actually just a slightly modified version of the Supermod. Put some very simple aerodynamics on it. We actually did some neat stuff on that. If you check out the website, I think the videos are still up there. This thing been punched up to about 4,000 or 5,000 feet or so. Switch the engine off. Let it fall back down, relight the engine as it's coming down, and then fly it back to the original path that it took off from. And it was one of the modes that we were looking at for our eventual suborbital vehicles, although I think we're pretty much close to abandoning that now. As part of the co-op agreement, so we originally sold the folks at JSC Pixel, and then we built the what was originally Project M and is now Project Morpheus. And the Hyperquad, the Morpheus, is just kind of a supersized version of the original quad, designed to run on LOX and methane. So we did quite a bit of work on LOX methane engines with them. And then NASA ran out of money before we did, and we couldn't carry on with the test program, so they actually brought it down to JSC. I think they use it now for keeping the grass down, is what I've heard. We've set fire to a few patches as well. It's a pretty impressive vehicle, and I think they're looking to fly that out somewhere in New Mexico as well, either White Sands Missile Range or maybe the spaceport even. And the goal there is to use it for testing ALHAT technology. As far as we're concerned, these are all dead vehicles now. They're kind of back in the museum. We probably won't build any of them again, and I say that a little bit tongue-in-the-cheek because in the last 3 months we've been approached by 3 different people about building these vehicles so they can test ALHAT technology, and we're tempted to do it. But our focus is going to be on Stig. Any of you guys fans of Top Gear? Stig was their tame racing driver. There's a couple of us are Top Gear fans. So we created the acronym, get the name first, then figure out what the acronym means afterwards. And it's Suborbital Transport Inertially Guided. That was my contribution to the project. Stig A1 flew not too well. Actually, flew really well. It just didn't land very well. Out at New Mexico back in April. And if the video gods are with us, we've got the video from that on the next slide. It's primarily designed as a flying test bed. When we first put this together, that's all it was so that we could test out the different technologies that we needed to apply to the next generation vehicle, which I think is the last slide on the presentation. I'll do the bit on that one later. Since then, we had NASA come up with what was originally the Cruiser program, and then now it's Flight Opportunities program. And as Will said, we were one of 7 companies that were awarded flights under that program, and we'll be using this vehicle for the foreseeable future to test all the technologies we need. The engine that's on there, that's actually the old version, but the engine that's on there will be one we eventually use for manned program down the road. That's Stig A1 out at New Mexico. That was, say, back in April. It's about 30 feet long, 15-inch diameter. This one had a payload in from the University of Purdue. We tried to give it back in one piece, but it wasn't quite successful that time. And then, do you want to mash the button on that one? There
Let's see if it'll work this time.
we go.
There we go.
10.
Sounds like it's stuck.
Yeah, it is
I don't usually count that slow.
good. It's all Cindy's fault. Let's see if we can.
Speed it. That should be, if you see what the file is, can you just...
That's what I was just going to do. We played straight from there.
We're all supposed to genuflect in front of a statue of Bill Gates before we do this.
What's the fuel for this?
Sorry?
What's the fuel?
This is Lux ethanol.
5, 4,
That sounds like it's going
1. There she goes.
Sorry. My fault.
I didn't want to see the last bit again anyway. It's painful.
Looks like we're curving.
That doesn't even look like we're coming.
It's out.
That was up to about... that was up to about 4... was it about 4
Any way
or
to fire
5
the parachute?
kilometers? Do you know how long it takes? You're going to
We
know how
have
long
a
it takes
separation
for something
event.
called 4 or 5 kilometers.
We're 3.6 kilometers up, 0.5 kilometers.
Every time we do this, I think it's just like flying a Ferrari Testarossa off the end of the cliff and watching it.
It's coming right for us. We have parachute is out.
They're hurting this
Come on.
way.
And we lost.
That vehicle was actually so overweight at that
Yep.
point it just stripped the chute lines.
Take cover, guys.
Yeah, that's how.
Safety, safety, safety. We have a level 2 emergency.
Coming down with smoke.
At the point it switched off, it still weighed about 1,200 pounds.
Shit, I lost it.
Curiosity, how far were you standing?
It's from California.
We got about like 2 or 3 minutes, technically. So.
Was it supposed to separate its nose like a giant Estes rocket type thing?
Yes. Yeah, nose cone comes out with a small balloon. I'll give you a little rundown, see how we're doing at the time.
So that part didn't work.
Yeah.
That's the Stig. Geometrically challenged, 0.4 meters is 15 inches, and 9 meters is about 28 feet tall. It's Lux alcohol. When Bert won the original X Prize, we switched from hydrogen peroxide propulsion. Probably some of the best folks in that at the time. But we couldn't get the longevity we wanted out the engines, so we switched to Lux alcohol. We're going to use this vehicle, as I say, for the scientific payload flights under the Flight Opportunities Program. It's a pretty powerful vehicle. Stig A1, this is the one we just watched making a hole in the desert for, was good for about 40 kilometers. It kept on for its full 50-second burn. Stig A2 is going together right now. In fact, we just finished radiographing the propellant tanks yesterday, so they should be going off to heat treat this weekend, and assembly will begin next week. We've got everything, including this new 5,000-pound thrust film-cooled engine. It's probably the best engine we built to date. It's going to be good for about 80 kilometers, so it's a pretty serious vehicle. The problem we have with Stig A1 was a roll control vane that just got stuck and jammed over, and it coupled in and gave us a nasty pitch yaw problem. And it decided it didn't like New Mexico, wanted to go back home to Texas, and the flight safety system did what it should do and switched it off. So Stig A2, looking to launch that in September from New Mexico. And following hard on its heels is Stig B, which is a slightly modified version of A2. Same thrust engine, but regen for extra performance, and that's going to be a true 100-kilometer capable vehicle. It's got that's the engine from the new vehicle. We tested that about 2-3 weeks ago. Another test going on Saturday morning. I'll get back in time. And it's designed to be clustered and staged. With clusters, I don't see too much advantage in the cluster. We have to take slightly heavier payloads up. But I'm really looking forward to launching. This is kind of like Falcon 9 or Stig 7 out there. With a stage version, we can take small scientific payloads up to several hundred kilometers and relatively inexpensively, considerably less than putting on some plate of black bread. I don't want to see that. This is what it's all geared up for. In the same way that the folks out in Mojave there with Virgin, we're partnered with Space Adventures, the only folks that have actually taken people to space commercially, with the Soyuz. We're in the same vein. We've got the design on the ground. We've got some hardware going together for this, but it's going to be 2012, I think, before we actually fly the prototype boilerplate vehicle. And Space Adventures have sold, I think, something like 250, 300 tickets. We're the Walmart of the commercial space business. Our tickets are cheaper than this. I think the going rate's currently about 120 grand for if you want to get on one of the early flights. The reason I'm doing this is, like you said, there's a whole market of folks out there that want to go. I was 11 years old when Gagarin went into space. And I decided there and then that I wanted to be an astronaut. Unfortunately, if you haven't guessed from the accent, I was born on the wrong side of the pond. And I could throw a rock higher than the British manned space program. After a small interregnum, I decided the only way this was going to happen was if we did it ourselves, and that's when I joined Aerospace back in 2000, not realizing this is where we'd be at this point in time. So you'll be able to see some stuff on the internet of that, and I think I'm going to need my beautiful assistant's help to mash this again. This is actually hyperlinked to the internet, so we'll see if we got any better luck with this.
Let's see if this will work any better.
I think Space Adventures only released this like 2 or 3 days ago.
Where in the world did I? Gosh dang. Or not. Oh,
Do we ask
You
a
played
question
this.
while you're waiting here?
trying again.
A film cool, are you're referring to cooling the engine bell? I mean, do you put fuel
I
outside?
do not know
of it?
why
What
it has
film?
disappeared.
It's actually on the inside wall of the
Your little
chamber.
mouse thing
If you look at the underside of the injector plate, we get our kind of patented pattern of oil and
I can't get your thing to work
fuel injector holes. And then around the periphery, there's a small row
So
of
you kind of
single holes.
spray more fuel inside.
Floods fuel down on the inside. It doesn't burn as efficiently. You get a little bit of finesse.
There's not a good mixing and all that.
Exactly. It actually does burn. Actually, if you can get it doing the wrong way around and have it burn outside the chamber, it makes a real nice crack.
We do have folks on the line, so if you want to answer, speak into the mic.
Okay.
Or at the podium.
This will actually use 8 of those same engines that we saw on the Stig B. Designed to run with all 8 for takeoff, switch off 4 part way through, so there's no black area. We can actually get rid of one set of engines and still land. The one thing they didn't do on this before they finished this first draft was I think it's still going to show this landing like the old supermods where it powers up to slow down and land. And I think right now we're working on a GPS, a steerable recovery system, GPS chute system. We'll be trying out on the Stig this next September. This is the point where we'd probably deploy a balut drogue like we're going to have on Stig, just to have it coming down base stable. And then about 25,000 foot, it'll pop out the parafoil. And we'll use that same GPS steerable technology the military have been using for putting payloads into hot territories. It's not that we couldn't do it that way, so we've already done that technology, not from that great an altitude, but we've certainly dropped the vehicle at terminal velocity and had it decelerate and land back on the pad that it took off from. The problem I have with that is I'm the one that gets to do the trajectory analysis, and my fuel load was getting to be a little bit cumbersome. So we're going to look at chute recovery. I think I probably overrun my time.
Yeah, it's okay.
Sorry about that. It's okay, because we can talk for a week.
Thanks. All right. Who's next?
So Kathy McKee's going to talk
Okay,
about
Kathy.
XCOR.
Great. Yep. And you have videos, right?
I
Are
do have
they embedded?
videos. Yeah, one will
Okay.
work.
Yeah, the clicker and
Right.
Either talking to the mics or if you want the handheld, I can give you that.
Yeah, as long as this works. As my colleagues have said, I do want to point out that what we have here are on this entire panel are NASA contractors. On one side, the orbital side, we've got the CC Dev, and then for myself and my suborbital colleagues, we have what we affectionately call Cruiser, which NASA now calls Flight Opportunities Program. So that was just announced last week, and congratulations, guys, by the way. I am Kaki Rodway McKee. I'm the program manager at XCOR. I do a lot of the writing, including the marketing. In brief, XCOR was founded in 1999. We are in Mojave Air and Spaceport in California. We have had 2 generations of rocket-powered vehicles that we've built and flown. We're right now building the Suborbital Lynx, which will be an FAA launch licensed vehicle. And we're funded by angel investors, sales, and contract revenues. And we are revenue producing. We like to say we've lasted since 1999. Our focus is on engines. We're a bunch of engine guys. We've had 12 years in this business with 14 engine designs and over 3,500 firings of those engines. We focus on safe and reliable rocket engines. Those are our top priority. And we have successfully demonstrated reliability, reusability, and safety of non-toxic propellants. We like to say that we don't use anything that you can't spill on the floor. And as safety is a very high concern, we've never had a catastrophic engine failure. However, we do put blast shields on everything just to protect personnel and property. Our other focus is on responsive operations. We want to make this a very routine thing. Nobody cared that there was a Southwest flight that flew in from LAX except me because I was on it. But nobody here cared about that today. That's what we want to do. We want to, the Lynx is flying today, and everybody goes, oh, well, yeah, great, thank you. Make it routine. Now, the Lynx, this is our suborbital reusable launch vehicle. It's horizontal takeoff, horizontal landing, 2 seats, a pilot plus 1, and we like pilots. We liked manned vehicles. We also like wings. It's a small vehicle. It's not quite 7.5 meters, and in that's the wingspan actually. In length, it's about 8.5 meters, and we're going to do aircraft-like operations. Again, responsive operations. We can take off from any airport with a runway of about 7,500 feet and the appropriate airspace. We use air traffic control. We don't use range operations. And we do this all with high-tempo operations. We intend to fly up to 4 flights a day. We will have rapid call-up, which is in about 4 hours from the time you want the vehicle to fly. The vehicle will fly. And then fast turnaround. We'll have a 2-hour turnaround time. So all that leads, all that leads to low-cost operations and maintenance. Low manpower. Again, non-toxic propellants allows us to have some fairly rapid operations and turn time. As far as Lynx Heritage goes, and I encourage all of you to go onto our website and see both of these vehicles in flight. On the left-hand side is the Easy Rocket, which taught us the development of safe and reusable propulsion. This actually started as a rocket engine demonstrator. Chief engineer took his long, easy plane, which was a Burt Rutan design, and took the piston engine off, put two 400-pound thrust rocket engines on there and said, hey, let's see if it can fly. Well, guess what? It did. Flew 26 times, broke a world record for the longest distance rocket-powered flight in a plane of this class, and that was actually flown by Dick Rutan, who had a blast, even though it was about 10 minutes. Dick got out of the plane and said, that was the shortest long-distance flight I've ever done. It also taught us low-cost and safe operational procedures and integration of an engine into an airframe, and it introduced us to the regulatory framework that has now become FAA AST, which is going to be licensing all of our launch vehicles. The X-Racer on the right-hand side taught us pump-fed fuel, enabled high performance for future ops, and I'll talk about our pumps in a minute, but we improved our low-cost operations and the safety regime processes, and we improved our airframe skill sets and our avionic integration. Again, this was a home-built plane, a kit that was built. We took a piston engine out and put a 2,800-pound thrust Lux kerosene engine on that one. In total, both of these planes flew 66 times, and yes, both broke a world record. On the X-Racer, we flew that 7 times in one day, and pretty much everybody in the company everybody who wanted a ride got a ride in that plane, including myself. But I can tell you on the day that we flew that 7 times, no one was happier than our pilot, Rick Searfoss, which is remarkable because Rick was a space shuttle pilot. He's been on the shuttle 3 times, twice as pilot and once as commander. But he was the happiest. It was quite impressive. Where we are in our Lynx development with respect to the propulsion, the main engines are a regeneratively cooled Lux kerosene. There'll be 4 2,800-pound thrust engines, a variation of the X-Racer engine. Very much heritage from that one. We've been test firing through thermal equilibrium. We've tested with a nozzle extension, and the nozzle extension is actually part of a contract that we have with ULA. And we're now testing for combustion uniformity and adjusting startup and shutdown sequencing. We're testing this probably once a week, maybe once every 2 weeks. It's kind of becoming routine. With the nozzle extension, that's a new technology. It's a lightweight nozzle that we fired, and yes, again, it's part of a work with ULA. The thrusters, let's see. That's our thruster there. It's a unique, non-toxic RCS. It's proprietary bipropellant fuel mixture that we have designed. Fabrication and assembly of this, what we call the 3N22, is complete. We're test firing it regularly every day at this point. We're characterizing the combustion efficiency as a function of combustion chamber length. We've got basically what we call a trombone chamber that we can adjust. And we're qualifying the propellant compatible components, i.e. seals, and make sure that they work with a propellant that we have. This is a fun engine in the sense that we have visitors come in, and we can go to our engineers and say, hey, are you guys busy? Can we fire the engine today? And it sits in our hangar. It sits actually right behind here is the front door. And the guys can go, oh, sure, yeah, 20 minutes later we're firing an engine. And it's to me, it's really cool to see because we can just, hey, let's do it. Let's fire the engine. That was not part of the plan. Fuel pump right here. This has been tested to full Lynx power. It's been tested on the X-Racer, so it's fully flight hardware qualified. The LOX pump, we've proven it on the bench test. The flight-ready hardware is now being tested. We've got about 30 minutes of runtime on that. We have yet to test it to full power, but we'll get there. We like to talk about our pumps. We like to talk about these piston pumps, which have a higher mass but lower cost than turbo pumps and uses an automotive legacy instead of an aerospace legacy. On I think combined pumps, and we've got LOX and fuel here. We've got 8 hours of pump time without wear. We expect the pumps to have about 5,000 flights before they expire. So that's just sort of our calculations. And we have tested the cryo capability on these pumps with liquid nitrogen, liquid oxygen, and liquid hydrogen. So they're all fully reusable and low touch labor after the flight. So again, responsive operations and low cost. Okay, well, let's run through it. This is that video that I need you to pull up. So I want to show you. This is just an engine run, a 5K18 engine run.
That is the static, right?
Yeah. Sounds on, right?
It was before.
Yeah. This is with sound. This is one engine run, just lots of different camera views. Yeah, it could be louder. But again, out in the Mojave Desert. This is what they do every week. It's another day. Okay. Where'd you hide it?
She has it set for the sidebar here.
There we go.
Remember that.
All right. So the airframe, CFD is done, subsonic wind tunnel tests are done, supersonic wind tunnel tests are done up to Mach 4. We've got more wind tunnel tests coming up. But we now have enough confidence to start fabrication of the airframe. The cockpit pressure vessel is pretty much done. Yes, we're fabricating. We're sending out bids for fabrication of that. Fuselage, same thing. We've got that going. Non-burnite is something that is a composite that we will use with our Mark II production vehicle for the LOX tank. We have a NASA SBIR contract for that, primarily to look at the manufacturing processes of that one. Mission profile looks pretty much like this. Again, I said we've got two vehicles with the Lynx. The Mark I, which is prototype, it's going to fly to 61 kilometers and provide about a minute of microgravity. Mark II, our production model. If any of you have heard that we have wet leases with folks like Spaceflight Curacao in the Netherlands Antilles, we will be selling, wet leasing, I should say, the Mark II, which is going to get up to about conservatively 100 kilometers and about 3 seconds of microgravity. We've got some multi-mission capabilities for research. This is the ATSA Suborbital Observatory. It's a camera that can do planetary and Earth observation. But we'll have in-cockpit experiments. We'll have externally mounted experiments like this one. of test pilot astronaut training, upper atmospheric sampling, microsatellite launch only in the U.S., not outside of the U.S. though, and of course spaceflight tourism. These are just some of this is where we intend to have the payloads. What do we do? We've got a couple cowling ports back here. It's about the size of a double CubeSat. Good for, we've heard it's good for atmospheric sampling and things like that. The pod on the top, again, you saw the last slide. And then internally, we've got space behind the pilot seat and the right seat, which is also where the participant goes, where the person goes. So that's about right there in the right seat is about a 19-inch rack. The Lynx experience, you're in the cockpit sitting, oh, you know what? We'll just let the experts tell you how this goes. They're much better than I am.
I am personally looking forward to. I can't wait to take it myself.
We need the sound here.
I experienced flying the shuttle, all of those
For real?
phases of flight are there. Boost the weightlessness. In fact,
Yeah,
it's up in a pilot seat.
But it's playing out extremely.
Yeah,
That's gonna
it's not. No, you need the sound for this one.
Because I have the computer sound up as high as it's gonna go. I don't. Yes, because I can bring everything all the way up.
You got the speakers.
It's piped into the what do you call it? It's piped into the overheads, which is.
It's a little better.
The experience is something
That's a little
I am
better.
personally looking forward to. I can't wait to take it myself.
All of the things that I experienced flying the shuttle, all of those phases of flight are there. Boost, the weightlessness, the fact that you're up in a pilot seat as opposed to being in the back like a passenger on an airliner. This is more like the right stuff kind of experience. The person who gets a ride on board the Lynx will sit side by side, slightly aft from the pilot. There'll be 2 sets of controls. We'll be wearing pressure suits to fly it.
It's about a minute after engine light to go supersonic.
We anticipate about a 75-degree flight path climb angle that we'll use in our trajectory.
Going faster and faster and steeper and steeper.
We're going straight up. That's a key element of it. Things happen in a hurry. That altimeter's clicking by pretty darn fast.
70 to 80,000 feet, the sky starts to turn dark. By 100,000 feet, it's gone black.
So once we get to main engine cutoff, we'll have a brief period of weightlessness, and the arms will kind of float.
And then you have several minutes to enjoy the view and enjoy for yourself the sensation of being where so few have gone before.
You'll also get an opportunity to maneuver using the reaction control systems, turn it upside down and pick different attitudes and just hold there. You're going to get a spectacular view. Be able to see out to the Grand Canyon, all the way down Baja, California, looking out, seeing the sun glint on the Pacific Ocean, and then from there it's just a long glide back home. But looking at the Earth from space, it's virtually life-changing. Really the key driver to what will make this experience so special.
Thank you.
So thanks again to our suborbital/orbital companies on that side of the room. So I personally appreciate it. I think the company I knew least about was XCOR. So that was exciting to learn about everything you guys are working on. Now we're going to transition to the orbital companies and those specifically working CCDEV2. We're going to start with the rocket, Mr. ULA.
Mr. ULA.
So Jeff Patton
Give it
is
Jeff a
going
new
to
name,
share
huh?
his great stories.
I like your new name, Jeff.
Yeah, I like that name too.
Supreme Commander's down there.
Yeah.
I have your charts here somewhere. There we go. Clicker and try and speak into the mics because we
Okay.
have folks. If you want a handheld, just holler.
Okay. I'll
go with the stereo thing here. See how that works for me. All right. Time shouldn't be a problem. Thanks for having me here. Appreciate it. I was here earlier. Well, you can't see anybody back there. You still there? I'm afraid everybody's wandering out from mine. Appreciate you inviting me back. I also appreciate you turning the heat up outside for those of us that came here from Denver. I'm Jeff Patton. I'm in the Business Development Advanced Programs group with United Launch Alliance, and I'm going to talk a little bit about what we're doing with commercial spaceflight today. And assuming I can figure out which button does what. Oh, that was not the right. All right, I guess I'm done. There we go. Ah, there we go. All right, I figured it out now. United Launch Alliance has been around for almost 5 years now, and during that 5 years, we've had 53 launches. This is kind of the family portrait of all those launches. It shows a mix of launch vehicles in there. Excuse me, Delta 2s, Atlas 5s, Delta 4s, and it's quite a variety of launch vehicles that we've launched in that time frame. A lot of different spacecraft, a lot of different missions, so we have a tremendous amount of experience and breadth in the things that we've launched and the experience that we've gained from launching those spacecraft and operating that myriad of different launch vehicles in there. 53 launches, 100% mission success on those, and we're very proud of that. Most importantly, our most recent mission is the NASA Juno mission, which launched here about 2 weeks ago on August 5th, and that was on an Atlas 551. That's our largest Atlas vehicle. It has 5 solids on it with a big 5-meter payload fairing on it. And we're very excited about that because it is a NASA mission. It's a very important NASA mission to Jupiter. And I'll talk a little bit more about that in a few minutes, but I do have here, if I can figure out how to get there. Oh, wait a minute. I did it earlier, didn't I? So I do have a video of this, and a video, especially with rocket launches, is a lot of fun, so hopefully this will be loud too. Oh.
Everything's a virus.
Go Atlas. Go Centaur.
T-minus 10. 5, 4, 3, 2, 1. Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter. Planetary piece of the puzzle at the beginning of our solar system.
Solids 1, 2, 3, 4, and 5 jettison. And we have payload frame jettison. Current altitude is 45.8 miles. In altitude, downrange distance 69 miles. Velocity 5,413 miles per hour. We have retros and stage separation. And full thrust and arrow. Centaur closing stern has been
The reason we're really excited about that is because it is a NASA mission. It's a very important NASA mission, and there's a whole series of NASA missions that we're launching here in the next several months. And so we get a little frustrated because a lot of folks are bemoaning the fact that there's problems in NASA. NASA has a lot of people think that NASA is going away, but obviously a lot of you are with NASA, and there's a lot of good things going on now, and we can't lose sight of that as we're kind of in a period of time when we're struggling with what we're going to do about human spaceflight going forward. NASA is still doing a lot of really good things. Juno is one of them, and there's a lot of other missions that we're working on that just underscore that. We have these 5 missions that we're launching for NASA in a 6-month period. The first one we started out was with Aquarius back in June. That was a Delta II launch. I talked about the Juno launch here on August 5th. Here in a couple of weeks, we're going to launch Grail to the moon. And then in October, we'll have an NPP launch on Delta II. And then it'll all culminate the day after Thanksgiving with the launch of the Mars Science Lab to Mars. That particular spacecraft is going to launch on an Atlas 541. That's essentially the same thing you just saw. It just has one less solid. And the Mars Science Lab is a fairly large vehicle. It's a small SUV size, and so that'll be pretty exciting. So we tend to get a little frustrated because there's all these really good things that are going on with NASA and a lot of good exploration that's going on. So it's very important to us to make sure that we support the agency and deliver those missions and do the job that we're here for, which is launching those things to orbit. So why is this all important? Why are we up here? Why are we concerned about commercial spaceflight, commercial human spaceflight? It's because of these all these missions. It's a little hard to see, and there's a reason for that. We kind of call this our rulers. Because they originally it was in yellow. It looked like something you had in grade school, but essentially it's just showing all the missions that we've launched going back to 2004. It's somewhat arbitrary. We could go further than that, but what we're showing is we've launched a variety of missions. We have a really good launch tempo, and we learn a lot from every single vehicle that's in there. We learn a lot from Delta IIs that has some applicability to Delta IVs, that have some applicability to Atlas Vs. So knowing all that stuff really helps us have confidence in how our vehicles fly and understand what can go wrong, what can't go wrong, and have a lot of confidence in those particular vehicles for human spaceflight. You can see our record of continuous mission success on the Atlas side. We're very happy. I'm very proud of that because we haven't had a failure since 1993, I think, 93, 94, and that dates all the way back to the Atlas II program. On Atlas V, we've had 27 successful missions in a row. Delta II is 95, and Delta IV has been 17. And so because of that success, again, we've learned a lot. And when you know how the vehicles fly, you know how they perform, that really lends a lot, that demonstrated reliability really lends a lot to our knowledge of how we would apply those vehicles for human spaceflight. We really think that system-level knowledge and the detailed knowledge of how every single component of that vehicle flies, that demonstrated reliability is key for human spaceflight. So that's where we make the transition into human spaceflight. So what are we doing now with commercial crew development, for example? For CCDev-1, we spent almost a year working on the development of the emergency detection system. The emergency detection system is the one thing that our vehicles don't have now, and the EDS essentially monitors the vehicle, looks for anomalous conditions, notifies the crew if there's going to be something going wrong, and gives them an indication of what kind of action needs to be taken. That was essentially the same thing that was done for the Atlas program early on when we flew John Glenn. We really had to go out and develop that system. We're doing the same thing now. We understand how the vehicle works, how it could potentially fail based on all that history we have behind us. So all that gives us a lot of confidence that we know how to go out and design that EDS. We designed algorithms. We did some tests at the end of last year to prove out that system would work, would catch failures, and it worked flawlessly. We also supported some of the spacecraft primes, the space vehicle partners on CCDev-1 to integrate their spacecraft onto an Atlas. And so we learned a lot from them about what things they're looking for a human spaceflight program, and they learned a lot about what kind of things we can offer, and it was a really good partnership and helped us continue on with the development of a commercial crew program. In CCDEV 2, unfortunately, we were not selected as one of the winners for that. I think we were probably far too successful in convincing folks that we were low risk to be able to fly crew, and probably too much so. And so we unfortunately didn't get any money, but we are still supporting 3 out of the 4 primes who've selected us for launch services. Sierra Nevada Corporation with Dream Chaser, Blue Origin, and Boeing just recently selected us after a competitive procurement, and we're glad to see that they came to the right decision. What we did was we talked to NASA and said, hey, we really want to keep the activities going on that we were doing under CCDEV 1 and that we planned to do under CCDEV 2, and we pursued and executed an unfunded Space Act agreement. And the good thing about unfunded Space Act agreements is that it allows us to exchange information between what we know about our vehicle and what NASA knows about human spaceflight. And so that's a really good thing. They get access into our processes, all our data, all our qual data, everything we have, we're making available to NASA now to try to understand what things that we would have to do, if anything, to human certify our launch systems. We've been saying for years, me in particular, have been saying there's not a whole lot you need to do because of the vehicle design. The only thing was the EDS. So now, fortunately, through this unfunded Space Act agreement, we have the ability to work closely with NASA to go out and dig through the details and present those details to NASA and get some feedback. So that's all the good things. The bad thing is there's that unfunded part of it, and we would have liked it to be a little different, but the good thing is that we are trying to get to a baseline, essentially, for human certification for the launch system. We're trying to get to that point at the end of the year, and I'll show you in a couple charts of things that we're doing between now and the end of the year to demonstrate to not only ourselves, but also to NASA that we really think that our vehicles are there. And because our vehicles have that flight heritage, on the Atlas side, especially having a heritage back to 93, 94, as far as not having a failure, we really think that in order to fly people, we can get the earliest ILC for commercial crew on Atlas 5. All 3 of the companies we're supporting have chosen Atlas 5 for their launch solution, so we think it's the right solution for human spaceflight. All right, this is a word chart. I'm going to summarize this fairly quickly. If you go out and go online and pull up our unfunded Space Act agreement, you'll see these in there as our milestones. The first one is our kickoff review, where we basically sat down with NASA and said, here's what we're going to do. Here's how we're going to show compliance to your 1100 series of documents, and make sure we and NASA were both on the same page about what we both mutually thought were required to get to that human certification baseline. The thing we're diligently working on now is what we call a design equivalency review, where we go through all the NASA requirements, bounce them against ours. So it's essentially preparing for an SRR, which you'll see in a couple of charts, but essentially it's going through all the 1100 series documents, which is NASA's set of documents for flying commercial crew now, and bouncing our design off of those and seeing how we comply, whether we meet the intent, whether there's some areas that we don't. And then we have to make a decision with NASA's help on whether that's okay or not. So we call that design equivalency review. We intend to take that down to the lowest level of design that's necessary to show that we are compliant or meet the intent of those requirements. And that's not a trivial thing to do. If any of you guys have ever done that kind of review, it takes an awful lot of effort to go through that. The next thing we're going to do is a probabilistic risk assessment, is trying to understand what are the hazards on our launch system that may require any design changes, may require additional monitoring, may require some sort of additional activities that we would have to accommodate for human spaceflight. We've done a lot of that in the past. We've done a lot of that for the Pluto mission several years ago. That was our first cut down that path when we were Category 3 certified launch system for Atlas. We've done that subsequently for the entire fleet, and most recently for MSL. So that's not unusual for what we've done. So all that data exists. So we have a good start on that. But focus on this is going to be on crew hazards, things that we don't necessarily consider in flying uncrewed missions. The next thing is the Tailored Systems Requirements Review. Again, that'll be more of a traditional SRR that will go through and look at the results of all the stuff we've done, the DUR, all the things associated with the PRA, explosion modeling, all the stuff that you'd have to do to show that you were compliant with those 1100 series documents. And then at the beginning of next year, sometime first or second quarter, we'll have a real live no fooling SRR once NASA baselines all their 1100 series documents or requirements. And again, we don't anticipate any problems there, but again, this is our first opportunity to really go through with NASA the details and go through the nitty-gritty. I think one of the things that you asked for us to go over was what's our schedule to kind of get to providing a crew launch. A lot of this is contingent on funding. That's kind of a standard answer is, it depends on what the overall funding for this program is. But essentially, we've always said that we could fly crew in 3 years. From our perspective, there's several things that are required. There's this crew vehicle integration where we have to work with Boeing and Sierra Nevada and Blue to make sure that their vehicles can fly on us. We think we could do an uncrewed demo in 3 years, and the first crewed flight at the end of the fourth year. We may have to do some specific, on the vehicle side, we may have to do some specific wind tunnel testing because the spacecraft that we're looking at now are different than what we've flown before between our 4 and our 5 meter fairings. The spacecraft are either capsules or they're winged vehicles, and they're just different. So the prudent thing to do is to go out and do some more testing. And that's probably the primary thing that we're most concerned about is doing that testing and getting confidence that we can actually fly these different configurations. But we're kind of the risky thing is we're kind of doing that in parallel with the design of the spacecraft, and we've done that in the past. It's just it's a worry item, but we don't think the risk is that great. There's the human rating, human certification work, and from our perspective, that's primary emergency detection system. Anything else that we may come up with from this DUR and unfunded Space Act agreement activities that we're off doing. Then you got to go out and modify the pad, and if you're familiar with what we do at LC-41 down to the Cape, it's a clean pad. There's really nothing out there. There's no way to get people in and out, which I think is kind of important to the spacecraft providers. They're kind of demanding when it comes to that. Yeah, that would be a yes. So that's a requirement from them we have. So we got to go out and figure out what exactly that is, and that's one area that could drive us schedule-wise. If you got to build a bunch of infrastructure out there that we don't have. And we quite honestly we don't know what that needs to look like. So we're going through that process as well through this Unfunded Space Act to try to help us understand what's required to get people in and out, because it's not as straightforward as one might think. So in order to get to a first launch, we could do a demo, we believe, in 3 years and start the first crew launch in about 4. And that's a pretty sporty schedule for a spacecraft design. So, I guess we're kind of challenging the spacecraft providers and actually the folks that dole out the money to make sure that they give us enough to maintain the schedule. I think one of the other things that you asked for in the outline, wherever Cindy went, assuming you're still there, anyway, was commercial crew barriers to success. And some of these things are very similar to what I talked about when I was here earlier this year. And it's unfortunate that they're kind of the same things because, the way we are now, we're kind of in a holding pattern and at best, and maybe a flat spin at worst. But what we really need is some adequate sustained funding to go out and do this. We need to be able to plan from year to year in order to meet that 3-4 year schedule to make this happen. That's probably the single most important thing. Procurement approach is important. I think we all recognize there's a lot of discussion now about Space Act agreements versus FAR or some hybrid between the two. And from our perspective, since we'll be providing launch services to a prime, that's kind of their problem, if you will. Yeah, sorry. I have confidence you guys will be able to take care of that, but it is a concern, and I think different companies have different approaches to that. Fortunately for us, we can operate under any of those procurement approaches, but I think we as an industry need to look at what's the best way to do this to enable this commercial crew capability to happen in a timely fashion. Requirement stability, we all kind of look for NASA to provide us with some guidance, and we're just kind of trained to think in that standpoint to get that kind of requirements driven design solutions from NASA, and as opposed to the flexibility that we have now on the Commercial Crew Program. So it's kind of a different philosophy, a different mindset. The most important thing is getting those requirements, those 1100 series documents, baseline, and the plan now, I believe that NASA has, to do that in December, which we applaud. The requirements are in some areas a little higher level than we're used to, and in some areas they're a little more detailed than what we're used to. So again, it's a give and take, and the earliest we can get that done and baseline, I think we're all going to be better off. And then the last thing is the inside oversight model. Again, a lot of us are used to working in that mode where we're getting a lot of oversight from NASA, and the Commercial Crew Program, as it's currently constructed, it doesn't have as much of that. So we're all operating a little differently, and it's going to be a learning experience on both sides. So we're going to have to wait and see how that occurs. That one actually flows right back into the procurement approach as well. So depending on whether it's a more traditional FAR approach versus an SAA, that those two are kind of linked. But the most important thing, like I said when I was here earlier, is we got to have that continued commitment to U.S. human spaceflight leadership. I think I'm sure we're all frustrated in here. There's not decisions being made because there's a lot of things we can go out and do now, and the more time we spend not doing anything, the worse it is for all of us. So we really need to get that continued commitment from our leaders to fund these programs the way they should be funded. Hiring prospects was kind of the last thing, and from our perspective, with the types of work that we would do and the support we would provide for hopefully all three of the spacecraft we're providing, we're going to need help across the board because at our current flight rate now, it takes virtually everybody we have just to accommodate our current manifest. So when we start adding human spaceflight and the complexity of human spaceflight, because even though I tend to kind of say, hey, it's an easy thing to go out and do, our vehicles are fine, it's still going to take an awful lot of work to make sure that we are comfortable with being able to do that. And so we believe that across the board we're going to need people kind of dedicated to doing that within United Launch Alliance. And so you can kind of see these are kind of a cookbook generic areas, but the message is when this happens, we're going to need an awful lot of help and a lot of people. So when's that going to happen? It gets back to that funding thing I mentioned earlier, so hopefully sooner rather than later. So with that, I'm done. Look forward to your questions.
Quick question. Is NASA your only potential client?
I can't speak for... In Commercial Crew, NASA is looking for an integrated solution. So from our perspective, that's why I said the procurement approach doesn't necessarily apply to us because we're supplying launch services through a prime. So as an integrated solution, it's up to Sierra Nevada and Boeing and Blue to define what that market is. Now, if I step back from that a little bit, we've been working with Bigelow Aerospace for years on trying to get a commercial crew capability going to help him. So, from my perspective, this is Jeff Patton, not ULA's necessarily's perspective, but I think there's a tremendous opportunity there for the types of things that Bob is looking at. And I think that's what we're all trying to get to in order to make the cost go down and in order to make this market really happen. It's guys like Bob that really have that vision of really exploiting low Earth orbit. So I think that's a tremendous market potential there. But it depends a lot on the decisions that NASA makes in that previous chart, how they're going to buy this thing and, what kind of requirements they're going to have. All that kind of stuff plays into that because all those things increase cost and make it harder for Bob to have an end-to-end service, both launch services and the spacecraft, that are affordable to meet his market needs.
Thanks, Jeff. So now that we have a ride to orbit, we have 2 spacecraft to launch. So next up is Mike Burghardt from Boeing, and he's going to tell us about the CST-100.
Yeah, there's the drawings queued up already. A moment. Oh, that's all right. Yours is up, but it's over here. Oh, come on. I actually don't know how to... Yeah, that should be full screen somewhere. There it is. And clicker's right there.
All right, thanks, Cindy. I'm the fortunate one out of this group. I had to drive 10 miles down the street from my office to get here. I'm the unfortunate one that I get to bear this heat every day. As you can see, or many of you know, Boeing's been involved in spaceflight with NASA since NASA's inception through its heritage companies, McDonnell Douglas, Rockwell International. And we've been in love with that capsule design since day one. We briefly broke tradition with the shuttle program for 30 years, and I don't know how they did. They got the North American guys to do that after the success for Apollo, but as soon as we got the chance to go to something new, whang, we went right back to that. So and there's some reasons for that from a commercial perspective. It's efficient design. We know how to do this. We've done this a lot. A lot of our team is old shuttle, heritage shuttle and station folks, so we're the old timers on the block, so to speak. We're trying to break those chains of that old space mentality here as we move forward. Let's see if we can hit the right button here. All right. So our premise here is really to leverage as much existing and heritage hardware as possible, minimize that development activity. There's a lot of good hardware that's been out there and flown for a long time. Some of it's a little more expensive than we'd like, but we're working with a lot of the contractors in that to identify changes to that to make that less expensive. So again, safe and reliable, as I'm sure all of our colleagues are, that's a number one tenet. Reduce that development risk, and that helps you both not only in schedule but cost as well. Our initial concept is to really design our environments to envelope a variety of launch vehicles. As Jeff said, we've arrived at a decision. We're going to initially work with the Atlas V vehicle, and if either the market demand dictates or traffic models and that, there's always an option to go a second launch vehicle, and that's what we're trying not to preclude that in our early design phase as far as selecting environments for certification. Jeff's giving me the look here. And everybody knows it's you can't design fully for everything. There's always some redesign if you go to a second vehicle, but it's to try to upfront not to make your decisions informed and wisely as you narrow those environment bands to limit the amount of Delta certification and Delta design work you have to do if that need becomes available. We're shooting for operational capability, first crewed flight at the end of 2015. And again, it's a complete transportation system, spacecraft launch vehicle provider through a proven launch vehicle system, ground operations, mission operations, and recovery. Again, this is the ConOps. Somebody asked earlier about other customers. As you can see, here's a concept of Bigelow Station. He's part of our team now in CCDev1 and CCDev2. And he's been very encouraging. In fact, he liked our interim design reviews we did during CCDev1 so much he held one of his own this summer. And all his guys were like, oh, we have to go talk about what we're doing? So we're learning a lot from them about how to be rapid and agile, and they're learning a little bit from us, too, as we go along here. Our spacecraft is kind of nestled between Apollo and Orion, or now as it's called MPCV. It can seat up to 7. Fully autonomous operation with a manual crew backup capability and an integrated aboard and on-orbit propulsion system in the service module. This shows kind of our evolution. We just started in December of 2009, actually before CCDev1 award at IDR1 there. And we've kind of progressed through the interim design reviews through an SDR. And then IDR4 was our last milestone in July here. Shows kind of the evolution of that design. Again, here's some more pictures. Shows 7 persons in the capsule, 1 pilot and up to 6 passengers. NASA's pretty much decided to fly approximately 4 crew members on a flight, 3 to 4, and we'd take the seats out and leverage that volume and that lift capability to fly extra cargo for them. And that'll be especially important to NASA because down mass is a critical item for us to continue to support space station and the scientific research up there. We land on land with airbags as our primary mode. These are basically the same design as the Gen 2 airbags that were developed on Orion for ILC Dover before Orion went to a water landing only concept. One of the things that's a tricky item always is packaging in the upper deck here with all the parachutes. And when you come for a land landing, you want to have close to being flat, not perfectly flat, but a lot closer to flat than when Apollo used to come in the water. So we came with a concept that we call it the bucket handle, which deploys up after main chute deployment to give us a near close to only a 7-degree hang angle to allow for that land landing. And you can see the propulsion system here. The 4 large engines are our primary abort system. These trace their heritage all the way back to Jeff's Atlas II sustainer engine. Have a long, successful history. They then, in the 90s and early part of this century, 2000s, they went through a program with PWRs, the maker of those engines, went through a program with the Air Force and NASA to see how cheap they can make them. They did a really good job of making a cheap, durable, reliable engine. The problem is they made it a little heavy. So what we're doing here now is take that design and kind of squeak back a little and try to get some of the weight out. And we expect to get over 50% of the weight out. And we're in their process of building that engine to demonstrate that at a test firing this February. One of the concepts we thought was fairly innovative from our CEV work and proposals, we proposed to build the crew module in 2 pieces. And what it allows you to do is you leave the pieces open, you put all the systems in there and integrate all the systems while the pieces are disassembled in 2 halves. When the pieces are put back together, that becomes a confined space, and it limits the amount of traffic to get in and out, so it limits and extends your schedule. By doing it this way, you can have a much greater workforce in there, much more touch labor, and reduce that. We took the work we did from the Delta IV development for the tanks on the Delta IV that Boeing did before ULA took over and operating that system. Done very well with that. And we took the concept of spin forming. And we take metal plates and we spin form them into this basic shape, then machine them, and then we bolt them together. And that makes we built this ground test article during CCDev1. We built it and designed it, built it in 9 months, and did 10 missions worth of pressure cycles, including 4 proof pressure cycles, plus a scatter factor of 4. Got to go to Earth orbit, you got to come home. You got to come home, you got to protect yourself from the heat of reentry. So we've been working on a base heat shield. This is one of the few areas we're looking to do a little bit of new design and development work. Ryan's done a lot of work on Avcoat and Pika, but they're very expensive. So if you want to get commercial, one of the things you got to do is you got to target some areas to reduce the cost, and this is one of the areas we've done. So Boeing's worked a lot on the shuttle program with advanced materials. One of the materials that we've had some experience with and spent some internal money on is called Boeing Lightweight Ablator, and we've been working with that to develop in CCDev1 manufacturing capability to build a full-scale base heat shield. This is a little over 4 meters. We went under our desired size because the facility we built at had a 4.5 meter autoclave. You got to have a little room on the sides to squeeze it in. We didn't want, so we cut it down a little bit just so we can save in some manufacturing costs for this demonstrator. We also took that material and did some ArcJet testing in the JSC ArcJet lab here. So we got to land too once we get back in the atmosphere. Like we said, the primary landing mode is land landing with airbags. Some initial tests here. I've got a video here. For aborts, or if you have a problem with weather, you may have to come home in the water, so you have to be able to land in the water. So we also did water drop tests. This is out at the pool at Bigelow. They use this pool for hydrostatic testing of their pressurized modules. Usually, a lot of times when you go in the water in the ocean, what happens? Waves come, you can flip over. Apollo had that several times where they flipped over. So you got to swing yourself back up to be able to get out. So we have uprighting bags, just like Apollo did. Probably a lot of people wondered, what are those big beach balls on the Apollo command module after landing? That's to allow the vehicle to upright after it flips over in the water. So we demonstrated the capability with our with uprighting bags to flip over with any one of the bags out. One thing Biggle is really good at is building models. So he built us a crew module mock-up, and we've put a this first generation mock-up. What we did is we built simulated controls, and they're really control panels that are mounted on Velcro. And the idea of this is you get the NASA astronauts in there, sit in there and put the panels on in the Velcro the way they want them, get the next guy in, and they always put them in a different spot. It's a lot easier to do it with Velcro than it is to do it with screws and nut plates. So that was our first attempt to try to find a little bit of a sweet spot there. It also gave us a chance to put in 7 seats and see how cozy it is. And it's not too bad. In fact, most of the astronauts, I don't know, you see this, the seat here. It almost looks like it's really a Recaro racing seat almost. And the crew, are we going to really get to fly with these? They won't be that comfortable. And here, this picture is good because it kind of illustrates the size of that volume inside. We built the mock-up in 2 pieces, and it splits in half. That's nice for when you take it to different places for display. You can open it up, and people can really see inside of it, and it makes it a lot easier to ship around, too. Let's see. There's 3 and then 4.
What's your mission profile?
To launch and a rendezvous and dock and have hatches open in 8 hours. So some of the other key things we did is the board engine. We took the Bantam engine, got one of them out of Marshall and one out of White Sands that they had in storage, and we actually showed that this engine worked with the injector design, was suitable design to fire with hypergolic bipropellants, and I'll show you a video in a little bit of that. Another key tenet of our system is we want to be able to autonomously operate the vehicle from start to finish. That includes rendezvous and dock. Boeing worked with DARPA on a program called Orbital Express where they approved in space, launched 2 satellites and did autonomous rendezvous and docking and berthing and propellant transfer with those 2 satellites. We've leveraged that system for our spacecraft. We have a lab, in Huntington Beach where the Vesta system was developed. This is like a motion picture movie camera platform. Runs on a set of tracks. That's hooked to a computer system with cameras on there. This is a quarter scale mock-up of the PMA. That runs through a T1 line to the lab, Avionics Systems Integration Lab here in Houston. That has like the first 3 seats. We have some CRTs here to do prototype display development, and you can see the lab developers in the background. These 2 systems are linked up. This system here senses relative position to the space station, feeds that data back to the T1 line to Houston. Then the single board computer simulating the flight computer computes the guidance solution, sends simulated signals to fire jets. Those signals are sent back to the lab in Huntington Beach, and that moves this camera platform to simulate the movement of the vehicle, and we can do a closed loop rendezvous and docking with that simulation lab. Okay. So here's our schedule. We're looking to do a PDR in February of this year, and approximately 12 months later, CDR. So this will be close to the end of the CCDEV2 time frame, followed by pad aboard, structural test, orbital flight test, ascent aboard, and then a first crewed flight. Again, schedule is based on leveraging as much heritage hardware as we can. Airbags, we'd love to use APAS. It's there, it works. NASA's still working on a 10-year plus development program for a docking system, so we're working with them to see, as I'm sure John and his folks are, on how to integrate that into our system and make that usable. Again, ablative materials that we have experience with, our structure, the rendezvous and docking sensors, the heritage engine for abort. Parachute system is the same heritage system that's gone from Apollo to Orion. and simple passive life support that traces its heritage back to shuttle and earlier vehicles. So we've completed between CCDev 1 and CCDev 2 40 milestones, all ahead of plan, working the preliminary design review in February. This week we're testing again arc jet samples in the JSC lab. We're dropping more airbag drop tests this week out in Dry Lake Bed on Nevada. And we're also doing wind tunnel test calibration runs out at Langley in preparations for wind tunnel test in Ames. So it's things are picking up very much. So let's go ahead and find the videos before we run out of time here. Show the
drop test, yeah.
That one. So this is video of the testing that was done out in Bigelow last year during CCW1, showing the uprighting test. July in Vegas is just like here, except a little less. At least during this test, the guys can jump in the pool. If we can show the rocket, the first part of the rocket engine testing, because
it's the
that one, yeah. This is the rocket engine test, the board engine test we did from February, and we did 2 tests with the same engine, and I will just show one of it shows multiple views of the same test. Board engine firing is about 3.5 to 4 seconds. This is a test site named Polaris out in north of Mojave. Yeah, we're not as nice as XCOR, you know, with the green. But it's hard to beat the bang for the mass for hypergolics. And unfortunately, we can't do this in a day. This is slow motion footage of the start sequence and start-stop sequence. A little chug of NTO there for start. And then the only difference in the other sequence is we ran the engine actually to propellant depletion and showed stable stable thrust termination. So that's it. Thank you.
And John, I guess that means you're it, huh?
So we have one more spacecraft to get to orbit, Dream Chaser. So this is John Curry from Sierra Nevada.
So what's the key stuff on this?
That'll advance it. That's the laser pointer, and that'll make it go back and forth. So you were on PowerPoint. Actually, F5 it. And should be good.
Okay, well, first of all, I apologize. I didn't, my marketing department's obviously not as good. So I put these charts together, and Cindy, I apologize. We do have some videos, but I didn't bring any of them, so you guys are going to be stuck just listening to me talk as we go through here, so I apologize in advance. I like the way Mike was joking about the transition between, Apollo and then shuttle and then Orion and then the capsules, and then, of course, I've got a wing vehicle up here, and I've worked all of those programs. And the one key thing about all of us here, you can tell, and I assume the folks in the room, is we're all a group of people bonded together to support a common goal here, which is spaceflight. And whether it's a capsule or whether it's a wing vehicle, I think they all have jobs. Shuttle and Soyuz, both of which I spent a lot of time with, worked very well together for many, many years. So spend just a couple charts on the company that I work for. I think most of you have heard a little bit more about us probably since the last time I talked, because I don't think Sierra, even when I came to work for him, it's been a year now. Jeff said he was shocked that it had been that long. I left NASA on July 31st, so just had my 1-year anniversary with Sierra Nevada Corporation. Been around for a very long time. They've done a lot of really good things. I'm not going to talk about all these other companies here, but it's broken up into seven different areas. The Space Systems Group is the one that I work out of. Our company is based out of Sparks, Nevada. Most of these other ones have to do with, on the Department of Defense side, surveillance, reconnaissance, intelligence type things, saving lives on the other side of the planet. Been very good at that for many years. But Space Systems is what I like to do, and that's what I'm part of. The Space Systems Group is actually based out of Louisville, Colorado. So even though a lot of you know me and have lived here my whole life, I still live here in Houston, and actually I'm the manager of what they call the Houston office for Sierra that we just opened up in February, because we are going to stay here. But our company that's building the spaceship and doing all the space stuff is out of Colorado. So I hang with Jeff. He's on the south side, I'm on the north side, so we just have to meet in the middle somewhere every once in a while. The two key parts that I'll talk about, there's 4 product lines, but I'll talk a little bit about the propulsion systems and then the space exploration systems, and that's where I tie in with what Will talked about, so I'm not going to spend a lot of time on it, but just so you guys know there's a tie there. And that's this page. And so Will Pomerantz did an excellent job, of course, way better than I could ever do, to talk about all the wonderful things going on with White Knight 2 and Spaceship 2 and what a wonderful job they've done there. But our company does, it used to be Space Dev back in the day when Spaceship 1, which is the picture you see over there, flew and did the successful flight test there. We built the engines for that, like he said, the laughing gas and rubber. Which is what we're still doing, and is a core tenet of our Dream Chaser design as well. And it's also the rocket motors. Will was talking about that there's ground testing going on with the rocket motors, and we're doing that in advance for them, and then integrating the system. And I don't know if these dates are all right or not. I didn't check with Will before I put this together, but I think this is approximately right on where we're going to do all the testing starting in next year. So Will, if I said anything wrong, I apologize. So what I think most of you guys want to hear about is the Dream Chaser design, which is the one that I have spent the last year of my life working on, trying to leverage all the experience that I had as a shuttle flight controller and a shuttle flight director, and then working the Orion project for the last 4 years before I left the government, MPCV or whatever it's called now, and I do hope that it succeeds because it's a wonderful vehicle. But we are building the Dream Chaser spacecraft. It is a NASA Heritage design. Originally, we always talk about the Russians stealing secrets from us, but this is one of those where it was the other way around. An Australian P3 took a picture of the thing. The Russians actually successfully flew this back in the 80s. I think the last flight was in 1983. I don't remember what my chart says, but it was in 1983, and we caught them pulling it out of the water. And so then they sent that up to Langley and asked Langley to reverse engineer it. So they spent a lot of time working on that. They developed the system. At that time, they were working on a thing called HL10. They evolved it into what they call the HL20. And so this vehicle is directly derived from the HL20 design. This particular model was one of the models that they had used, and they have other varying sizes. I don't have the pictures of it, but this is one of the base models that we still have in our offices there in Louisville that was used to form the basis of the Aero database that we are improving upon today. So a lot of people don't realize that that was 8 years of work by the government on there, and that's one of the things that I think that the company way before I got there did right, was taking an existing design that even for a brief period was supposed to be the replacement of the space shuttle, and for politics and not technical, it was put on the shelf. Have you guys ever heard of where NASA can't make up their mind on what's next? And so this was one of those that happened to. So here's the ConOps for us. Basically, I think somebody asked Mike what the basic picture was for us in terms of we're going to be obviously launching on the Atlas V, like Jeff said. Jeff did a good job of showing you what a wonderful design and in fact, I'll talk about that in a minute so that we don't have to waste time and can get back to pictures. This is the basic on how the vehicle looks. It's 7-passenger capable. So you got basically a pilot and a co-pilot, and then you got 5 in the back. The ConOps we have for the NASA side is that probably one of those guys could be a blue suiter type that would be doing the harbor pilot, what Jim likes to call it if you got up close to the ISS. It could be a Sierra guy as well. Steve Lindsay, if you guys know, just came on board for us, and I think he probably plans to be in that thing pretty soon. But whether he does or doesn't execute the docking would be one of those things we'll work out with the NASA guys when we get there. And then 5 passengers. And Mike mentioned the ISS. The requirements we've got is to bring 4 crew up and down from the ISS crew rotation with the ability to bring them home in a deconditions case, which obviously a winged vehicle is very good at doing. And so we're very capable there. When you see a picture here in a minute, the pressurized cabin, we've already built all this structure, and we're already working on outfitting the whole vehicle for the first drop test next year. So this is basically what you got on the launch on the Atlas V, and this is what I started to talk about a second ago. There's a reason we're on the Atlas V. There's a reason why 3 out of the 4 companies are on the Atlas V, and it has nothing to do with Elon. He's got a great rocket. It's just, it needs more time, in my opinion, and that's not Sierra's opinion necessarily. That's just what I think. And so being on there, and I think he had 98 consecutive Atlas-type launches with 27 Atlas V launches with 0 failures means something to a lot of us, and I think that says a lot. And we have been working with ULA directly way back, Jeff's doing the right thing and talking about both of us plus Blue Origins, who isn't here, but we have been working very tightly with Jeff's team on making sure that this rocket integrates. He is right. When you start talking about an unfair design on the top, you got to make sure all that works and make sure that NASA and us are comfortable that the aerodynamics work well. And we are doing wind tunnel testing, and we are funding wind tunnel testing right now. The system we're trying to deliver, and what I've been, when Jim Voss brought me on board for this, is we're delivering a system. This is not just about the spacecraft. We've got to make sure that this whole thing works as a system, and we've been spending a lot of time on this. A key thing, I don't know if I have it on other charts, I want to mention on abort capability. No offense to capsules, but they do have to go into the water and some of these things on aborts, and right now we don't have any black zones. We can make it back to a runway for all the abort cases, and I think that's significant as well. 7 crew, like I mentioned, suited for the ascent and entry phase is the plan. 3.5-day capable, so when you've got 3.5 days worth of consumables, including electrical batteries, is what we're using. I don't know if that's what Mike was using or not, but that's what we're using as batteries. So you size that to make sure you can cover all the basic cases. We can do a flight day 1 rendezvous like Mike just described, but an old flight director, I like the second day, just because of all the things you have to do on flight day 1 to get ready. We could do 1 if required, and as a matter of fact, Lindsay started giving me grief that we should move to flight day 1, so we'll argue about it and see what happens. But right now it's flight day 2 as the nominal, with flight day 3 rendezvous as the backup to provide the capability for consecutive launches on each day. Undock to landing, because we are a winged vehicle, we need to land on a runway. We want to make sure that the weather's good before we undock, and then we'll undock and land at KSC SLF as the prime. Of course, we can do just like shuttle. We can land at Edwards as an alternate, or any other site, frankly, with the wings. So we've got to figure out what's the right plan there, and we're working on all those scenarios right now. a big thing about what we're doing, and this is funny on how these things work, is we do have auto land capability into the vehicle that we've designed inherently. And in fact, the first drop test we're planning to do next year will be an unpiloted auto land drop test that we're wanting to do to prove out that capability as well as the Aero. Deorbit and low G, I think you guys know the differences. Like I said, capsules have a lot of advantages and probably quicker to get there. We'll see, in terms of the PDR capability, because our PDR plan is a little bit different than Mike's, and I'm very confident that they're going to be able to get there. Like he said, it's a wonderful company. Our vehicle is also doing very well because of the heritage that we got with the wings, and we think that this is the long term for low Earth orbit, that a winged vehicle has a value because of the payloads, because of the crew, and the low G profile that you get when you come home, and the cross range capability that you got. There's a huge advantage in a lot of things that you've got on this particular page right here. So for the undock, entry, descent, and landing, I like this vehicle's capabilities, as I like shuttle, and we're going to miss that vehicle. The other thing, it's gone back and forth. It's kind of funny about the props. So just a reminder on ours, I think Mike was showing the nitrazine and the nitrogen tetroxide, which is a very effective high ISP system. We are rubber and laughing gas going uphill with those hybrid motors, and then on orbit we're dual use on the nitrous. And so the nitrous is with ethanol. So again, a system that you can just walk up to that vehicle once it's landed and not have any issues. And that's the whole reason for that. Taking the lower ISP that you get, that's so that you can increase the ground turnaround capability and be able to launch sooner, which gets into the commercialism of space and the business case that we're trying to do. So that's the big picture there. So just a little bit about where we are. We are executing basically a flight test type program, build a little, test a little, keep progressing, keep moving as fast as we can. I think Jeff did a good job of explaining about the budget. Having worked around for 4 years in Constellation, I'm very familiar with when you are not funded appropriately, how you struggle. So the goal is let's just keep going as far as we can with the money that we've got available, whatever it is that it comes, because as you guys know, with the congressional system that we have, nothing is for sure. And you got to do these things in about 2 to 3 year centers, because then they just change regimes and it starts all over again. And that's the reality of what it is. We can ask for more money and we're going to get whatever we get. And then the question is how fast we can go. Jeff's point was, to make the 3 years work, you really have to have an X amount of dollars that we all know what it is to take to get there. So we're building, we're going to keep building these articles. We are building this engineering test article. We got a head start with it during CCDEV 1. This was what the pressurized cabin I was showing earlier. That is real hardware. It's already been built. It's down in Centennial, Colorado, being outfitted with the wings and the airfoils and all those things on it now, so that we can do the drop test of it out on the West Coast next year. And then after that, we will do a suborbital vehicle type thing, where the difference between Spaceship 2 that Will had, it's along the centerline axis. Well, that's where we dock. If you guys look at the old pictures, so we've got rockets on both sides. So we're going to want to do some flight testing of that kind of capability too, firing 2 engines simultaneously, making sure you can get up to altitude and then come back in. So that's being planned after the ETA. We turned that team over to the structures team, especially to get ahead up so that we can be ready to do that in the mid-2013 time frame, and then the orbital vehicle is in 2015, just like everybody else showed on the charts. This is where we are with CCDEV 2. So we have already, the stuff that's in yellow there, we've already executed. I don't have the details listed here, what all of them are, and I apologize. For example, we did just deliver a flight simulator that is really well put together. I was impressed with the way that we're able to move and make decisions quicker and cheaper. As an aside, for example, I don't know if you guys know Stokes McMillan, but he's one of the ones that works with us now, and so he's an old simulator guy. And so he came in and asked Jim Voss if he could have $4,000 to paint the simulator. He'd gotten a bid, and he said, "No way. Are you getting $4,000 to paint that thing? We don't got enough money for this." So, we want to put it into material dollars to actually build the hardware. Even $4,000, which is a different level of zeros from when I was working at NASA before. And so, and And Jim always puts it, treat this money like it's yours. And I agree with that. And so anyway, what did Stokes do? He went out to Sherwin-Williams and spent $86 of his own money, which we did fund him back for, by the way, and painted it over the weekend. And that's a true story if you guys ever see him. And that simulator looks wonderful. And for $86, not a bad deal. I wish I had the picture of it. It would have done it more justice to see how good it is. And then we did our SRR. That was the first thing it is. PDRs seems to be my thing. The last two things I did for NASA was the Orion and the Constellation PDR, so I'm working really hard to try to get this vehicle, the architecture. Any of you guys doing spacecraft design, we've got to get the architecture set, or you're not going to make it. And so Jeff was joking about the spacecraft needing to make the timeline, and that's really tough to do, to make sure you can show closure, and the things with mass, like Mike talked about shaving off a little bit for the engines. All of us have that. We can't get away with fit from physics and trying to make all that work. So we got our system definition review is coming up. We're already in the subsystem design reviews that we're doing in advance of the system definition review as milestone 5 there. That's going to be in October when we have the board. And the Vail, we're delivering the avionics integration lab there. We've got Draper is on our team that built the primary avionics, and Boeing actually is on our team that's building the emergency system avionics and software, and actually the avionics for the engineering test article that we're planning to drop test that I've mentioned a couple of times. And so these are the drop tests we'll be doing for the ETA in the summer of next year, and this is just the milestones we've got listed there. So as you can tell, you got the road to PDR, which is at the end of CCDev 2, and then some testing that we've got there and delivery of real hardware. So the full ETA will be delivered, at least the structure, before the end of this year, and then that's when we start outfitting it with all the avionics that we need to do the drop, so that we can then take it out to Mojave and do all of those things there. And we still have coordination work to do. I should make a huge plug for Scaled and Virgin on the wonderful work that they've done. So on a non-interference basis with the Spaceship 2 program, we've asked if we could kindly utilize that wonderful bird that they've got there, and we promise not to hurt it, so that we can do some drop testing out of Mojave. We'll actually do the captive carry and the taxi and a tow tests on the Mojave side, and then we'll do the drop out at Dryden because it's an unmanned bird, and so you need to do that on the Edwards Range to execute that. So I think that was my last chart. So I apologize for no cool videos. But, thank you.
Thank you very much, John. So I don't know if anybody else noticed, but there was a recurring theme through tonight's presentations that even though different companies come from different backgrounds or different parts of the country, they're all linked together. And we all come from, I love John's quote that, it doesn't matter whether it's a winged vehicle or a capsule, we're all bonded through spaceflight. So that's making its way around Twitter, by the way, just to let you know. So what we want to do next, we are running a little bit behind, but that's okay, but we want to do Q&A. So I'm going to invite all the panel members to come up and sit safely behind the table. We didn't have a table for them last time. And we have mics for you. And in the audience, we invite you to ask questions. We have our online participants who are going to ask some questions. And I left my phone up there, but I already have 2 that I was ready for. And the first one is for Virgin Galactic. Okay, guys. Yes. We really do have an audience.
Do you want to leave one mic at the table and leave
Yeah,
one for
well,
running, or you want to just
where's the other one? Oh, okay. I was going to say leave one here, and then they can use this one. Put one at that end of the table.
It's already on, so it's still blurry for your breath.
Okay, so I have the first question. I do. Okay. The question is, will someone please ask Will about this report Virgin Galactic is planning in flight or in space internet access?
All right.
The question for those of you on the webcast who didn't hear it is, will someone please ask Will if Virgin really is going to offer in-flight or in-space internet access? I have to say, if our passengers are using up their pretty precious time in space, I like Twitter as much as anyone else, but put the phone down. So that's kind of my take. We'll see. Like I said, I like Twitter. Twitter is great, but yeah, hopefully our passengers are not clamoring to look for their Blackberries and iPhones, well in outer space.
So, I guess the question for whoever wants to build it. So, here in Houston, we have MOD and we have United Space Alliance that have a vast experience in manned operations. And how are you utilizing that experience to design into your design and also as you go forward?
Sure. I think the bottom line, I'll just summarize the question, was, this is the mecca of manned space flight, basically. And I think he was pointing out that, we want to make sure that we can retain that capability, and what are you guys doing about it? Is that close enough to what the answer was? And I apologize, I should have mentioned this when I did the presentation. You mentioned USA. They've got a wealth of experience. They're on our team. Obviously, I wanted to have them very carefully, so we have folks working from USA, both on the KSC side and on the Houston side, working with us to bring the ground systems, the mission systems designs up to the PDR level of maturity, and we're also working on all the operations concepts, the system engineering. We use them a lot for the trajectory stuff that we're doing, all the abort cases, that kind of thing. USA is a big part of what we're doing, just like ULA is. The other thing you mentioned about JSE, Space Act agreements go the other way, and I forgot to mention this. So we have already signed a Space Act agreement with the Johnson Space Center to do work with them. So you start with an umbrella, and then you do annexes, and then you basically pay Johnson for their expertise or their facilities. You can do the same thing. We've also got Space Act agreements pretty much going with every center around the country. Kennedy, Langley, and Johnson have already been signed. We're working on the one with Dryden so that we can do the drop test. We did a scaled drop test with them last year via Space Act agreement. So with Johnson, it's a huge amount of work. There's they're doing the docking contact conditions for us right now, just to establish what range and range rate do we want to approach the vehicle at, so that when we come to the ISS that we do it right. So we're paying Johnson for that work. Also, a lot of the suit development work. Up to now, NASA hasn't edicted a suit, and so which seems odd to me. I would have thought they would have said, hey, all of us had to use the same suit, but they haven't done that. So we're working with the Johnson Space Center. We've got a lot of expertise there. Thermal protection systems, a lot of expertise out of Johnson, actually, and some of the other centers. I hope that answers a lot of the questions. We've got a lot of work there. Draper Lab, I actually mentioned, Draper's out of Houston as well, and MDA is one of our teammates. Somebody else can probably
answer too. Yeah, we're using, working with the USA as one of our partners for Boeing. They're leveraging their expertise, especially in crew training. They supported the Mission Operations Directorate in crew training, so they're helping us develop crew training plans and ground team plans, both mission controllers and that. We've also talked a little bit with the MOD Director, Paul Hill, about how we could cooperate and leverage their facilities and their experienced people, and we're just starting that discussions, but we're talking with them about that. As I said earlier, we're doing ArcJet testing this week and next week out at the JSC ArcJet facility. We're out at Langley this week doing wind tunnel test calibration runs in preparation to go cross country to Ames to do wind tunnel testing there. We're also talking to White Sands about some of the on-orbit engines firing programs for doing that out there. So, and talking to Kennedy about facilities out there for the future. So, again, we're like Sierra Nevada, leveraging a lot of that capability that's already out there.
Yeah, and I should have mentioned, just like Mike, Paul's an old friend of mine, and we working with Kelly Beck right now we plan to execute out of here. So mission control will be Sierra Nevada. We're working on the agreements, like Mike said, to make sure that the price point makes sense, but that's what we're working on, is that the plan is we will be executing out of Houston. And so that's when we can start having more people come to work and actually stay in Houston rather than right now the spacecraft's being built in Louisville. But that's the plan.
So, Will, I have a response to your answer. And somebody says, first of all, she wouldn't be putting her phone down. She wouldn't be reading, but she'd be creating content. Just putting it out there. Huh?
Is that crap flags?
Did anybody in the audience have questions?
I have a question.
Here,
Hi, my name is Mike Smith. I'm interested in the HL-20. When you have to land it after an abort, where do you take it into that has a runway that's big enough to handle that?
So that's a good question. We have done a lot of analysis on what the contingency capability is of the vehicle, and right now what they're looking at based on the landing speeds and the weights that we've got assumed that we could land in a contingency, one-time use, right, where we're just trying to save the crew, we're not trying to keep the airframe to use it again. We can land on as short a runway as 7,000 feet. So you can pretty much land on any runway, and so when you look at the aborts, obviously just like Shuttle had what they call the East Coast abort landing sites, we're looking at all the right ones for Shuttle to make sure that we can make the turns to get there. The difference between Shuttle and Dream Chaser is we have put the crew on top where God meant them to be. I think that's a Homer. That's not my quote. That's a Homer Hickam quote, I think, but I actually agree with it. And so you then fire those rocket motors for 46 seconds, and it takes you up to altitude. And so then you can, even on a pad abort, I can land at the Kennedy SLF, which is tough to do. Obviously, Shuttle would not be able to do that. For example, if you had an accident, God forbid we'd ever had an accident on the pad, which we did not.
I'm going to throw this out to all of you on the panel because it could apply to any one of you. But for those of you mainly, I guess, that are going to be flying your own crew on a regular basis, do you have any plan or have you thought about at all radiation management? Any increased exposure risk to your crew? Some of you may be at that point, some of you may not. I'm just curious.
You want to answer this, Mike?
Sure.
Too?
So we have requirements for radiation. I think most of us are going to be the same way. As the majority of their time, like going on your station flight, is going to be on the station. So right now, I know in talking with NASA, we anticipate NASA wanting to have a blue suiter in that pilot seat. So I think NASA's preferred in our discussions modus of operandi would be almost like the Enterprise lease. They take it out and you give them the keys. You operate it with them from the ground, but they want to have their guys flying, and that's better because then you don't have to spend time on a Boeing person or a Sierra Nevada person or a Blue Origins person flying. You get a revenue passenger. You have to give them a little more training, but as we all know, those NASA guys are capable of doing it.
Mike said it well, that the risk is low because of the time period that you're talking about, and the ISS does have some protection, but it's also low Earth orbit in general. And Steve Lindsay just mentioned the other day, this question came up in a different thing, so I'll just quote him. He flew 5 times. One of his times was up to the Hubble, and then the other 4 were in low altitude to the ISS. He received more dosage in the one Hubble flight than he ever did in the other 4 that he was at ISS, much lower. So that where you are in the low Earth orbit with the station is pretty benign when you're talking about radiation. It's the flights to the moon and those kind of things that Orion, back when I was a Orion guy, we had to spend a lot of time on.
Yeah, is that on? You made the comparison wing vehicle versus a capsule vehicle, a little different way to look at it, but have you ever looked at it as a comparison to the Russian Soyuz, the existing crew vehicle?
That's a capsule. So
I meant more system-specific comparison.
I'm not sure I quite understand, but in terms of the overall capability of Soyuz, because we've worked a lot, I think Mike and I's design capability is fundamentally the same. I think Soyuz has it right in terms of what's the min set that you need to do the job. So it's basically 4.2 day capable. I don't know exactly what the capsule is that Mike's got, but it's going to be somewhere in that range, right? And ours was 3.5. So I think they got that pretty well. They have Peggy Whitson, when she came in, I don't know if you guys remember, there was an umbilical that got stuck on the back end of the service module, and the only reason she survived is because of the stability of that shape. And so once it burned off the cables, the vehicle was being shook around and burned off the cables, and then the vehicle reoriented itself, just like Will was talking about on Spaceship 2. And so she and her crew survived. So the Soyuz is a good from that perspective. I don't know if that was your question.
Do you see it as the competition or the system to improve on? You have to do better than they are.
Than the Russians? Oh, absolutely. The key thing that my boss always says, and I'll tell you, is there's already a commercial program going on right now. It's with the Russians. We are paying, the United States government is paying the Russians for seats. $65 million per seat for an ISS person, a NASA person to fly up to the ISS, $65 million per seat. That is the goal. That's his goal, that's my goal, and Jeff Patton, we were talking about how many different customers he's got. That's a good thing. It gets the price of the rocket down so that we can actually beat that, because it makes no sense to me to be feeding the money to the Russians. They do a lot of things well, but we're the United States of America. The shuttle has been retired. We need to get that back. This is not about us making money. This is about returning manned spaceflight to America.
I think John's got it right on. NASA, between when we start flying and the commercial community starts flying and the end of the station, they'll probably spend upwards of $500 million or more to move crew and cargo. Now, would you rather send that to the Russians, the Europeans, and keep their aerospace industry actively involved in operating and designing new hardware, or would you rather spend it here in this country?
And now that the shuttle's retired, we'll see if that $65 million per seat stays the same.
This is for Mike on the CST 100. You said that your baseline landing was on land.
Yes.
Where's that land going to be?
So right now we're looking at two sites, primary sites of either White Sands, Wismar Lake Bed, or the lake bed at Edwards Air Force Base. And we're in the process. We'd like to have a third contingency land landing site that gives us a little more separation, that gives us more deorbit opportunities, preferably in the continental United States.
Okay, so you're going to be able to come down by parachute that accurately?
Yes. If you look at the Apollo data, they were pretty much within less than a 4-kilometer circle, all the way from the moon.
That scares me. At least you didn't say the Ukraine or something like that.
Does anybody have a suborbital question for one of the companies?
Yeah, for Armadillo, you mentioned that you're now looking into the guided parachute recovery. Is that going to be a unpowered landing, or are you going to kick the engines back in at the end?
That's a really good question. Our original concept was, which is why we were testing with the Supermod, was to actually have a fully powered landing, so it would free fall, probably with a small ballistic drogue just to keep it nice and stable, and then do a full powered landing. So we've demonstrated we can do that from fairly significant speed, but I ran into problems with propellant management, keeping enough on board for all sorts of emergencies. So in this next round, when we developed the Stig vehicle, we started looking at just conventional parachute recovery systems. And about halfway through, we thought, boy, for the original cruiser program, we had to land within 1 kilometer of the takeoff point. That's real tough with conventional chutes. So that started us down the road of GPS steerables. So right now, the concept is that the balloon will come out up top. It'll free fall, base stable, and then we open the GPS steerable at about 25,000, depends on the winds aloft. But there's still going to be some drift with that. Our subcontract Waymore, who are really good folks to deal with on the GPS steerables, they got some huge military contracts, think they can flare it and slow that thing down. I like rocket engines, so we're actually going to, as you say, use the rocket engines to kill off any translation and just give us a really slow descent. Can't do that with the Stig vehicle, but the boilerplate Hyperion, which is the last one we saw on the slide there, will actually use that concept.
I have a question. On that long, slender vehicle that you fly, does that have an aft-mounted gyro to stabilize the thing? I noticed on the way up it was
Yeah, well, that was the roll control vane, which was the problem on that flight. And I still think actually it was the rocket was homesick and it just wanted to head for Texas when it could see over the side of that mountain range on the other side of White Sands there, and it saw Texas. It just wanted to go home. But it was a roll vane problem, which is why you saw that shimmy. In fact, even from the takeoff, I could see that the response was just way too slow on the roll control. But it has an IMU GPS system in there. It's a fully gimbaled engine, and it should be rock stable. If you look at some of the other flights we've done with that same flight control system, it's as steady as a rock going up. But that was a roll control problem. This next vehicle, Stig A2's got a dual roll control, and we've done some more software magic on it to make sure it flies with less roll than that.
Oh, sorry.
You said that that a lot of this technology is heritage from NASA.
It was me. I apologize.
Oh, okay, it's heritage from NASA, and yet you guys are also creating some. You have some new ideas, new things coming up. Are you patenting these things, and you're accumulating intellectual property now? I mean, we're commercial. We're not a government organization anymore. So I'm wondering if we're creating IP value in these companies as you go along, and are you getting patents granted from the old NASA programs?
You made them speechless.
I can answer that from an Armadillo Aerospace standpoint. Our founder, John Carmack, hates patents with a vengeance. In fact, there's a lot of stuff that's come up from his software side of the industry. One of the reasons that we think we're successful is the cycle time that we have. As John said, if you try to develop a game and you could only fly it once every 6 months, your cycle time for getting a game to market is going to be hideous. And he's applied that same process to building rockets. I mean, it wasn't uncommon for us to do 5 or 6 tests a day, and then go out the next day and do another. I mean, I'm talking not just firing an engine. I'm talking about flying a vehicle. If we crash a vehicle, usually we're back in the air again inside 3 months. So that's one of the crossovers. And just as a general rule, he has hated patents. He thinks the open software idea is one of the things that's driven the speed of development in the computer industry. There's some things I think I'd like to keep to ourselves, but I'm not sure how successful I'm going to be in doing that.
I'd say for Virgin Galactic, the answer is probably pretty similar. I think Bert Rattan has the same sort of personal opinion about patents. So if you look at the Spaceship One program, I think there's, I could probably count the number of patents associated with that program on one hand. A lot of it is processes and sort of know-how that you can't patent and that you're not really interested in patented. But that said, I think we're creating an enormous amount of IP value, and just as Spaceship One did. In fact, we're licensing the Spaceship One IP value. It just wasn't in the form of patents.
And there is a question from Twitter asking, what are the panelists doing to get more interest from the public, and how important is that to their success? With the follow-on of, are you going to do tweet-ups? Is also kind of a part of that, I think. So, let whoever wants that one.
Well, I think at Virgin Galactic, we're lucky that we're part of the larger Virgin brand, which is, one of the best-known brands in the world. I'm a fairly new Virgin guy, and I remember I had spent the last 6 years working at a nonprofit, the X Prize Foundation, where a big part of my job was begging the media to cover us. And my first day at Virgin Galactic, I got on a plane and went to a conference in Orlando, and the fact that my boss, our CEO, was in Orlando made the nighttime news. That it makes it a lot easier to spread the word because we have this well-established brand that we can lean upon. And certainly, as a space line, we're a little different than the others up here because we are contracted someone else to develop our technology. Our business rests on us being able to spread the word. To an extent, while the ticket prices are what they are, we're spreading it to a fairly small community, a fairly targeted community. But we hope, and I suspect the others on the panel hope as well, that our ticket prices will pretty quickly come down to the point where doing sort of mass marketing becomes much more of an issue for us.
Take that. Yeah, everybody at XCOR works to get the message out. Coming to panels like this, we're also involved with a group called Teachers in Space, and Teachers in Space has come to the hangar and talked to us and seen our facilities. That is an incredible organization. And that, as far as getting the word out to the public, I mean, I think it's really important to start with the kids and to start with the school kids. So Teachers in Space is an outlet for doing that. Basically, you know, I mean, I grew up glued to the TV watching John Glenn orbit, watching the moon landing. Kids these days, and even actually the kids, the guys coming out of college, now didn't have that. There was a shuttle that was kind of far, you know, few and far between in their lifetime. So here we are. We're actually getting this. Well, put it this way: there's the STEM, the Science, Technology, Education mission that has come out of NASA, come out of the President's Directorate, and start with that and go from there and go with the education of the younger generation. And with that, we can get the word out and tell the greater public about what we're doing. I mean, obviously, there's also the general stuff that we're doing, that sending out press releases and letting you all know what we have coming down the pike.
And just one other thing, a couple of us are in Mojave, and in Mojave they have this cool event called Plane Crazy, which is it's the third Saturday every month. It's a Saturday every month, and we don't have hardware out there every month, but we often have hardware out there. So things like tweet-ups are sometimes difficult because of this little thing called ITAR, but we try and offer those opportunities whenever we can.
I think we experimented with a tweet-up during the landing test, the drop test we did this week. Did you know if that worked?
I wasn't invited.
No, you were trying to set it up with Mike.
Oh, well, that was to tweet out the information.
Yeah.
But you have to get it cleared and the right video quality, and the mayor, no, maybe the president has to sign
Boeing's
off
a
on it
little
too.
harder than some of the independent.
Yeah, hi. Other than the humidity, what would be the one thing that you would, and you know, the question was asked about JSC working with you and things like that. What would be, two questions, by the way. What would be the one thing you would like to see changed, or that you would have in Texas, the government do, or something that would enhance your ability to work down here? That was my first question. Second was, if Texas had a coastal spaceport, do you think you guys would be flying out of it?
Well, I guess in terms of the Texas delegation, or what would help with Texas, it's been interesting to me, and this is just me talking, to see how the state of Florida has handled commercial spaceflight versus the way Texas has handled it. It's interesting. With their government, they have a thing called Space Florida, who basically goes out and tries to incentivize folks to come and put their infrastructure there, manufacturing, operations, those kinds of things. And I haven't seen that from Texas, you know, at least not as aggressively as I've seen on the Texas side. So right now we're working on where we do offline processing, how we'd get the spacecraft to the vertical integration facility, those kind of things. And they put out, you know, requests for information, and then basically bring a proposal back and says, here's how we can offset costs for you. I would love to see Texas have something like that, because I've lived here, I still live here. And part of that, the fact we didn't get a shuttle was devastating to me, and I think there's some accountability on some of the part of the folks that are here. I'm sure Kay Paley doesn't like me saying that, but I just feel like we could do better. And you know, and to embrace commercialism, there's both. You know, we're not in competition with the MPCV. That's got a totally different job. Its job is to go beyond low Earth orbit. I endorse that. It's not one or the other. It needs to be both.
I'll just tell you from an orbital mechanics standpoint, launching out of Texas doesn't help a whole lot, and it doesn't work real well for us. Now, you know, there may be other solutions out there that come along someday that may work, but right now it just doesn't work real well.
I have a question. SpaceX is trying to acquire a lot of land on Padre Ranch
had a big conversation they had with the governor's office and getting money. You know, so they, I don't know what trajectory they're going to fly out of, but you know, they seem to think that there's something there.
Actually, I'd like to chime in on the Texas thing as well. We're a Texas-based company. We flew our lunar lander challenge missions, the ones that actually won revenue right up in Caddo Mills, 40 miles outside of Dallas. Limited altitude. We've got no chance of launching anything significant out that neck of the woods. We wanted to launch in Texas. We would have been launching out in West Texas. There's a site they had, I think it was labeled Pecos County, just to the southwest of Fort Stockton. We would love to launch out of there. It's perfect for what we want to do with our suborbital flights. But I think there was some chump change thrown in for a study. Couldn't even get past the environmental review. There was a launch site that they were going to open just on the coast down here. And I think it got to the point where they had town meetings on it. We would have launched from out of there if we could have done. We intend to go orbital down the road. We've got to learn to crawl before we walk, before we run. And it won't be, I don't be competing for missions to the ISS. But we do intend to put scientific payloads up as our kind of next step. And coastal Texas would do us just fine, to the point where we're even talking about launching from the Gulf if we can't find a land base.
Okay, so we have one last question in the middle here, and then we're going to adjourn after some closing words.
All right, hi. I have a question for the commercial crew. It's a bit of a tough question, I guess. It seems like competition is going to be pretty fierce. Is there enough room for 3-4 companies trying to provide the same service?
If it's just the ISS, no. The key, I think, to commercial crew being able to expand is to start with ISS and go beyond. You know, Jeff talked a little bit about Bob Bigelow and Bigelow Aerospace. They want to put up a private station. They're basically waiting for one of us to come step up to the plate and show we're ready to take his crew up too. You know, he's part of our team. I'm sure he's talked to some of the other guys out here too. He's looking for a ride, and not just for not for the station. He knows he can get a ride from Jeff. He's looking for somebody to carry his crew, his people that want to go and do research and science on his station, or just go up and visit the station. So he's waiting for us, and once we prove we can do it to ISS, and he puts his up, and that'll open up the market, start opening up the market, and hopefully we can get that price down by having enough flights, and then somebody else come along with a third destination, and that'll start opening the market. But if it doesn't expand beyond ISS, it'll be very difficult to get beyond two going to ISS.
Mike's right. The ISS is the anchor tenant, right? But that's not the end game. So all of us have a business case on what we can do beyond the ISS. For the ISS specifically, a wise person once mentioned to me that what are we doing? Are we trying to replace the Soyuz, or are we trying to replace the shuttle? And those are two different jobs if you think about it. And so the lifeboat job might be more easily achievable with a capsule design. If you're just there and doing those kind of things. If you're interested in microgravity science or deconditioned crew and trying to make sure that the ride home is more benign, that might be a different job. And a capsule shape is the G's are a little bit higher versus the shuttle-like type capability that we had. So there's two jobs there that could be done. Right now they've asked us to meet both. So, we're designing for 210-day capability just like Mike is. But a wing vehicle, with 210 days, I'm going to have to work, hard to figure out what's the right thing and how much protection I can put on the thermal protection system to make that work. Or I need assistance, probably. And we'll have to work through all those kind of things, because obviously if you work as an integrated system, you can. But there's two jobs. How many companies they actually fund beyond that is totally a function of Congress and what comes out of that. And then I think they'll probably, how many they're going to down select. The question of how many they down select to, I think, is a function of funding.
And from our perspective, if you've ever seen Bob's manifest, he's got like 25 flights a year, which, it would be a great thing, because then you can have a lot of different spacecraft providers, launch vehicle providers, maybe maybe not too many launch vehicle proprietors. But I think that's something we all want to see happen, you know, and like I said earlier, Bob's a visionary, and we really want to try to do everything we can to enable that. The way it is now with gestation, with a couple of flights a year, and with depending on how we structure the program, that may never happen. So we're kind of at a turning point here to enable that to happen. We would also like to see space station utilization be increased. That would be a big swinger to help enable this.
Yeah, that's a key point, what he just mentioned. Right now, the rotation rate is every 180 days for the crews, basically, and that's driven by Soyuz. So if you can get that down to where you're rotating every 3 months or so, first of all, you could envision a scenario where somebody, a principal investigator, that's a national laboratory now, maybe you bring the PI with this experiment, he's only up there for 3 months, which is enough time to get data and then collect it and bring it back home. You know, 6 months is a long time. Jim Voss, my boss, stayed up 167 days, and he said he was tired of it when it got to the end. You know, 3 months is good, and or something like that, but you got to get that flight rate up, and then it enables so many other things in terms of access. That 523 or whatever the number was Will had, we need to get that number up.
I think even some of the NASA internal studies have shown that the crew office, about that 3 to 4 month time frame, their proficiency starts just go down. Like you said, Jim admitted 6 months on orbit's a long time.
It's Soyuz driven.
Right.
There's no reason that we have to do that.
So if we can get the cost down to a reasonable level where it makes sense for NASA to fly 4 times a year, 5 times a year more, that helps them because it drives down the cost more. It brings more people to the table that want to go use that national lab that we've invested in.
So I would like to volunteer for any of your companies to be a test dummy. I may work at, or may not work at one of these companies, but they haven't accepted me for that position yet. With that, I would like to thank all of our panelists for coming to Houston, except for, Mike, who drove down the street. Oh, wait, no, I mean thank you too, sir. I don't know about you guys, but I've learned a lot tonight, and I appreciate them taking their time.